Now we take a look. How can we distribute the key, secret key, and mainly the session key, using what is called asymmetric encryption scheme? Which, I mean, the main subject or the main goal of implementing the public key encryption scheme. So, generally speaking, someone said, can you use a public key encryption scheme to perform normal encryption? We said no, because it's not efficient. And you're aware why. Because mainly you have a, let's say, heavy computation, exponentiation, etc. So that all the operation is going to be expensive. Yeah, that's why we don't use the public key encryption scheme in order to perform normal encryption, but we can use this one in order to perform signing, digital signature, certificate, we're going to see this one later, or exchange the session key. That's the main purpose of the public key encryption scheme in general. The problem with this one, actually we talk about different, algorithms. You see that at the beginning, last week, not the week before, we start talking about the key management. We said mainly we have two main algorithms in order to exchange the key: transport or agreement. Key transport, that means you can use RSA. Yeah, we have one party have the key, it's going to encrypt the key using the public key of the receiver and send the key. Or key agreement, both parties going to communicate together, both of them are going to participate in order to generate the key, which is the key, what they call using Diffie-Hellman key exchange. But all of them require that you have somehow managed to exchange the public key. I'm not going to say securely, public key must be public, but you have to, when you said this is public key of Alice, anyone else can check, oh, definitely this public key of Alice, no one else. Let's show you, go over the Diffie-Hellman key exchange very quick. Then I show you that every single, we talked about this one before, we said every single public key encryption scheme is vulnerable to what is called man-in-middle attack. So we need to figure out a way, how can we solve that? I'm going to show you why this happened and how can we fix this issue. For the Diffie-Hellman key exchange, the Alice and Bob, each of them is going to have, let's say, create a private key and public key and exchange the private key, the public key. So Alice is going to take this my public key, a private key A, okay? A random A, which is going to be the private key, yeah, between 2 and P minus 1. Yeah. Then after that, they're gonna do what? I'm gonna have create a public key with any value. It's gonna be computed alpha raised to the power A mod P. Yeah. Now I'm gonna exchange the public key with the value of A. So it looks like I'm gonna send alpha A, and B is gonna do the same thing. It's gonna use a private key P, then raise the B to, alpha to the B mod P. Then it's gonna apply or send alpha to B. For Alice, in order to this is the share of the key. For Alice, in order to generate the key, is going to take what? My value alpha of A multiply by the alpha to B, that was public key part of the receipt from Bob, multiplied by my private key. And the same thing here. You're going to say, okay, I received that what I received from Alice, and I will multiply by B, my secret part. So mod P, and this is the key that we can use in order to perform the exchange. So we managed successfully in order to exchange the key. But we do have a problem. Any public key encryption scheme that, as we said, is going to vulnerable what's called man-in-middle attack. So what does that mean here? Let's take a look here. So Oscar is going to do what? It's going to intercept the communication. It's going to say, okay, it looks like Alice and Bob to do the key exchange. When Alice sent her part, alpha raised to the power A, okay, then, and Bob tried to send his part with alpha raised to the power B, Oscar is going to intercept the communication. So instead, I'm going to forward alpha raised to the power A, or the public key part of A, I'm going to send my public key. So Oscar is going to choose O, which equal the private key is Oscar, okay? Then Oscar is going to generate his own public key. So I'm going to show you how to perform that. So you're going to substitute, instead to send alpha raised to the power A, I'm going to send my part, Oscar. And here I'm going to send my part here. Can I do this one? Yes. I just forward my public key. Or the alpha to raise to the, let's say, the private key. With the public key, or the public part. Then here, each part is going to do what? I receive alpha raised to the power O, and there is multiply this one with my shared secret key. And I receive, for example, alpha raised to the power O. I cannot tell, but I thought this is from Bob or Alice, and I will multiply this one with my shared key. This one here for the Bob or the Oscar, this have different color here. The Bob would communicate with Alice is gonna do what? I have what? I receive alpha raised to the power A multiply with A. Alpha raised to the power A and multiply this one with my let's say private key. And also the communication part between Oscar and Bob is gonna say what? Looks like here I received what? B, I'm gonna multiply with my secret part. So you see here, it looks like we have a two Diffie-Hellman key exchange between Alice and Bob, Oscar, because this is the key the same here, and we have key exchange between, let's say, Oscar and Bob. That's what happened here. Why? Because the problem here at either the Alice and Bob, when they receive something, for example, this alpha A raised to the power O, they don't have any way in order to confirm or validate whether this public key belongs to the Oscar or the Bob. We cannot tell here. Can you tell? You can't, because they'll give you value here. And the same thing for the Bob here. When you receive the public key of Alice, they say, okay, he said, yeah, great, that's the public key of Alice. I don't have any way in order to validate whether this public key belongs to Alice or not. So in other words, the public key exchange here announced it's not authentic. So anyone can send something and say, hey, for example, I'm sending email and say, hey, it's me, Bob. This is my public key. Can you confirm that? No. Based on the exchange information that we have? No. So now, when Alice tries to communicate with Bob, Alice is going to send something. He's going to encrypt it using this key. Okay? And then encrypt it with alpha OA with the message. Oscar intercept this one, decrypt it, see the content, maybe modify it. Then after that, if you want to send it the same message or modified message, you're going to encrypt it using between the Oscar and the B and send it to the Bob. Do you see that? So that's the issue with any public key encryption scheme. So how can we solve that? One thing here, someone has said, okay, so we have a problem here. So that means, I cannot use a public key encryption scheme? No, we can. We can solve it. It's going to be easy to solve that. So it looks like we need to have like somehow, when you receive something, certificate. It looks like, how can you prove your identity to me? Right now, I can't tell. But in person, maybe you come to my office, then you show me your ID or your driver license. Why? By looking your driver license, I'm sure 100% or confident that, oh, that's your driver license. Because we trust an entity which issued this driver license. I know we do have many driver licenses not valid, but assume that all the driver licenses valid, or somehow you can check, or maybe you can use call DMV in order to double check whether your driver license is valid or not. Yeah, you can't confirm this information. Anyway, so we need to have what? Someone has said, so do we need to have a secure channel to exchange our public key? No, we need just to have what's called authenticated channel. So what does that mean here? This means we need to create a channel between, let's say, Alice and Bob. Using this channel, when you send someone, anyone can take a look to the content. But when any party, either Alice and Bob, when you receive something, they can't verify, they can't tell whether this information is authentic or not. Okay, so it looks like we need to add extra piece of information. I'm going to talk about this one later in more details. So first I need to do what? Go back to our original problem, that how can we use the public key encryption scheme in order to exchange this key, or the secret key, or the session key in general. Then after that, we're gonna take a look to how can we solve the issue or authenticate the public key in general, okay? So we do have many ways, many techniques. We can go over this one, okay? The simple one we can talk about is the simple secret key distribution, which is a very simple use of public key encryption to establish a session key. Then after that, make it better. We take a look at the secret, to say, key distribution with the confidentiality and authentication, add more features, make it more secure, better. Then after that, to show you what we doing currently. We're gonna have a hybrid scheme. Okay, we're gonna have the public key plus the key distribution center of the master key. We're gonna take a look how can we use them. Okay. Because so it looks like we have one problem with so remember when you work with the key distribution center, you need to find a way how to distribute the master key. We're gonna distribute the master key using the public key encryption scheme, and thus, thank you very much, public key encryption scheme. We're gonna continue our work using the asymmetric encryption scheme in order to encrypt, the session key. I'm gonna go over this one. What does that mean? what we using these days. Let's take a look at the simple one. This is easy, let's say very simple scheme. So here, the requirement of this one, of this proposal, this scheme, allows secure communication. And there is no key before and after the protocol gonna exist. You are not gonna store anything. Okay? And we emphasized that it's gonna be only useful if the attacker cannot modify or insert the message. In other words, works only for the passive attack. If someone just observed the communication. Let's go over this one. Alice wanted to communicate with B. We need to distribute the key. Yeah? So Alice is gonna do what at the beginning here? So Alice is gonna do to say generate the keys, a public key, private key for her. So in this case, Alice is gonna say, okay, this is my public key. I'm trying to use the same notation, public key A, and the private, we call this one the private key, say A. Okay? And Bob is gonna have, okay, this is my public key of Bob, and this is my private key of Bob here. Each is gonna have its own public key. Okay? Although we don't need this information here, it depends who is going to communicate. Assume that Alice is going to communicate, establish the connection. So this information must exist for Alice. Alice is going to say, okay, hello, this is my public key, and this is my ID. This is me, Alice, and this is my public key. Send it to the Bob. Bob is going to say, okay, I trust you. I don't have a problem with you, but it's simple. So I'm going to do what? I'm going to create a session key here. Encrypt this one using the public key that you give it to me. I trust you. Then I will send it back to you. When Alice receives this message, the only one can decrypt the message in the good, if there's no attack, okay? So it's Alice, because Alice can decrypt the message here using the private key of Alice, and Alice can get the session key. We use KS, yeah? Let's say session key. After this point here, Alice is gonna say, okay, I don't need these keys anymore. Okay, I'm gonna keep the session key. Once it's done the communication, I'm gonna delete the session key. This is the simple algorithm we can do. So again, Alice is gonna generate public key and private key, send her public key to the Bob. I said, hey, we're gonna establish communication, we need to see your key. Let's have a simple algorithm. This is my public key, this is my ID. Bob is gonna generate a public, let's say private key, or let's say session key, encrypt use the public key that I received, I trust you. Then Alice is gonna decrypt the message and they get the key. Of course, yeah, this only works in the passive attack. Passive attack, someone intercept the communication, just monitoring the communication. You're not gonna modify anything, okay? And the good thing here, someone is saying, why you don't need to, store anything here? Because if there is no key exists before and after, that means you're not gonna worry about, you say, whether the key gonna be compromised or not. Because they use this one, once you're done, you're gonna delete it, okay? So that's it's subject to the man-in-the-middle attack, definitely. Why? Because right now, if you said man-in-the-middle attack, that means it works only for the passive attack. But if it's active attack, no way, it's not gonna work, because someone is gonna intercept the communication. You're gonna say, okay, great, Alice and Bob communicate. Hi, this is Oscar. This is the public key of Oscar, and this ID is Alice. Send it to the Bob. Bob is going to reply with encrypt using the same key, because I don't have a way in order to make sure whether the public key belongs to the Alice or someone else. So I trust the system here. Encrypted with the public key of Oscar through the session key, and Oscar is going to decrypt the message and get the session key, and maybe it's going to encrypt the session key as the public key to say for Alice, and Alice is going to have the session key. When you try to encrypt the message, Oscar's going to be able to intercept the communication. Because they intercept the communication, I know the part, or they say the session key used here. So far, so good? So let's take a, how can you solve this one? Okay. So in this case, I'm going to show you how can you provide protection against what's called both active and the passive attack, because I don't like this one. So in this case, we're going to add what's called confidentiality authentication in the system here. So assume Alice and Bob try to communicate. So here it's going to be more exchange of the message. So the first here, Alice for us is going to start to communicate. They're going to say, okay, this is my public key. Of course, you have the public key, Alice, and the private key of Alice in order to use a public key encryption scheme. Okay? And at the same time, Bob is going to have, this is my public key of Bob, and this is my private key of Bob. Each of them gets generated to create, to say, its own public and private key. Alice is going to encrypt the message, because I don't want to make sure Because the goal here is that, what? I need to provide the protection against both the active and the passive attack. So we need to hide, confidentiality, authentication. Let's see. So have Alice, this one, Alice and Bob. Alice is going to send the message encrypt using the public key of Bob. Okay, we assume that somehow I know the public key here for Bob here, and this one knows the public key of Alice before we start the communication. Good. You're gonna take the public key Bob, encrypt what? Nouns in one, and this is my IDA. Why I need to include the nouns here? I need just to make sure that this transaction is unique, and at the same time, when I need to challenge Bob, if you are Bob, no one else, you are the only one can decrypt this message, right? So you can reply if you include whatever the nouns value that you found in this email or this message with your response, so I can know for sure that I'm communicating with Bob, no one else. You see that? How can we? This is challenge and response. I challenge you with something. If you are the person he claims to be, then prove it to me. How to prove it? You are the only one who knows the private key of the Bob, because you are Bob, no one else. So you send the nouns here with the message. You say ID. Bob, decrypt this information. You're gonna say, okay, this nouns in one, and this IDA. Let's create a session key. Let's encrypt the session key with the public key of A. Reply this one. You say with A. Then after that, you're gonna say what? I'm gonna say this is the N1 and also this N2. First, I need just to authenticate, make sure this is the guy who claims to be. Okay. Then I'm gonna send it to the Bob. To the Alice. Alice is gonna do what? It's gonna retrieve the message and say, okay, looks like we decrypt this one. I found N1, the same one that I sent it. So yeah, I'm communicating with Bob because I encrypt this one using public key Bob. What else? Oh, he challenged me again. Before we exchange the key here, we need Alice and Bob. Each of them is gonna authenticate the other party. So it's gonna be the message 1, 2, and 3 here. When you perform this operation now, how can I authenticate myself? I'm gonna say what? I'm gonna use the public key of Bob. Okay. I'm gonna do what? I'm gonna encrypt. Let's say I'm gonna sign the session key using my private key. Okay, it looks like you sign something. You sign the session key after you generate. Say I've said here the Bob is gonna generate the session key. No, actually here the Alice is gonna generate the session key. Bob can do this one too, but that means you're gonna exchange this one later after you receive the confirmation or response from Alice based on whether again confirm that you're receiving the nouns in true or not. So encrypt the message. Before I encrypt the message, I'm gonna sign whatever the session key. Encrypted this one using the private key of Alice for the session key. Then I'm gonna encrypt this one with the public key. So here we have the session key. It's gonna be encrypted using the private key of Alice. Then that one is gonna be encrypted using the public key of, let's say, Bob. Yeah. When you receive the message there, Bob is gonna use the private key in order to decrypt the message. So it's gonna get what? The private key of the session key. Then it's gonna decrypt this one using what? Using the public key of Alice. So you manage to get the session key. You get this one? I know it's complicated a bit, but we have a confidentiality authentication in exchange of the session key here. So far, so good? The hybrid is different here. The hybrid means what? There's another way in order to use the public key encryption to distribute the secret key. Okay? So in this case, we're gonna return or keep using the key distribution center. So we still have Alice, we have a Bob, or whatever, just for simplicity, 2 users, and we do have the key distribution center here. Okay? So we still have this one. So somehow we need to find a way in order to have what? The key distribution center are gonna have the key encryption key or master key between Alice and key distribution center, and the master key between, let's say, key distribution center and Bob, and with every single user. Okay. So they're going to use the public key encryption scheme in order to distribute the master key. So the way that exchange the master key between Alice and key distribution center, we're going to use the public key encryption scheme in order to take care of this operation. So the public key is going to take this operation. How can I perform that? The key distribution center public key is going to be known by Alice and Bob. So even we can use the previous step in order to manage instead to exchange the session key. We're going to use this one in order to exchange, let's say, the master key. Then after that, once we use the public encryption scheme, that means we're going to use n times here, if we have n users, in order to exchange the master key with every single user at the key distribution center. Then after that, I'm going to say, thank you, public key encryption scheme. Done. We're going to use whatever algorithm that we have that bases the key encryption center and the symmetric encryption scheme, which allow me in order to exchange the keys, the session keys. Okay? How can you distribute the session key? I'm going to use the master key that I exchange or distribute using what is called, the public key encryption scheme. Okay? So that's what's going to happen here. Of course, we're going to show you a different story. How can we exchange the key? How can we authenticate? We need to add another layer of the security in this system to make sure that the public key, for example, here that we use in order to exchange the key or the master key with the key distribution center and every single user must be authentic. How can you do this one? We're going to cover this one using the, let's say, the next part. I give you different ways to do that. Then we end up with the best way, with the one that's used currently in the web secure applications. How can you distribute the public key now? The product here. How can you make sure when you receive the public key is going to be, let's say, authentic? So the simple thing we're going to perform here, we have in many ways, okay? The simple one I'm going to show you. It's going to be just public announcements. So it looks like someone is saying in the middle of the class, say, hey guys, this is my public key. Or maybe send email to the iit.edu, say, hey guys, this is my public key if you wanted to communicate with me. Or maybe put this one on a website, or maybe magazine or newspaper, whatever. Anyway, in order to publicly announce your public key. Of course, this is not a good solution. Then after that, we're going to take a look. Maybe we're going to put the information like publicly available directly. It looks like a phone number. Yeah, you are young guys. You don't know that. In my days, when I try to search for the phone number, I have to go to the big book in my house in order to go over all the names, in order to figure out which phone number I need to call. Or let's say the yellow page, something like this. We are going to do this one electronically. We have one place folder that's going to be able to say, or it's going to be published periodically with all the public key available in the system. If you want to looking for a specific public key, then you can check that public directory to get the public key. We're going to see why it's not a good solution. Then after that, we have one entity, more secure. We call this one public key authority. Then after that, we say the best solution ever that we have so far, we're going to use what's called the public key certificate. Okay, let's go over one at a time and see why it's bad, why it's good. So here, as I mentioned, going to make what is called public announcement. Okay, so when A tries to work or communicate with B, A is going to say, hey everyone, this is my public key. And B, hey everyone, this is my public key. Do you think this is secure? No. Because maybe, how can you tell when, for example, IOC, for example, something you say, this is public key of Bob, public key of, let's say, Charlie, etc. When you see this one, can you tell whether really this is public key of Bob or not? No. Because here someone can intercept this communication and say, hey, this is my public key. This is B. And this is my, this is Bob, and this is my public key. I change this one with Oscar. Or maybe this is not B at all. Maybe this is Oscar. And you say, hey, I'm B, I'm Bob. This is my public key. So this is not a good solution. Okay? Anyone can announce a key pretending to be another user. And you cannot tell. So it's like a project is not going to be discovered until, say, that guy discovers, oh, someone else maybe impersonate my identity. The second thing, or the second solution, we can do this one using what is called the public key directory here. Okay? So in this case, I do what here? So everyone try to access the system, gonna say it's gonna publish this public key, not announcement. It's gonna put this one, let's say, publish this public key into, let's say, public key directory, like a shared directory. Everyone or public directory can access this one electronically. So every single user can access the system and gonna say, okay, this is my public key, then I'm gonna publish my public key or store my information there. Okay? So in this case here, of course, you assume that when you go there, you have to authenticate yourself. You have to tell, this is me and this is my public key. Here we don't have a problem. The problem here, if someone else tried to get your public key, so it's going to go to this public directory because it's going to be published online. If this server, let's say this entity, is going to be compromised, maybe someone else can modify any public key. At the same time, when you receive the public key, I don't have like kind of the trust or enough degree of the trust to tell me that I'm confident. I say, oh, this is a public key that belongs to Alice, no one else. I cannot tell. You get this one? So someone, you get information, say, okay, this is the public key of Alice. Can you check this one? No, because you have to trust whatever information you're going to find it here. So just speaking, the information is going to be what? The user, ID, and the public key of the user. This is like the entry is going to be stored here. So just you fetch search, then you get the information. The same thing when you print out, you have the phone directory. You're confident that the phone directory is correct 100%, but there's a mistake. So if someone is to modify this one, you change one page or modify many pages and print out and publish, you cannot tell the difference. So you trust this one open, but there's no way in order to be authentic 100% or confident that the key that belongs to the person that you claim to be. So then how can you do that? We're going to do something better here. Or again, if someone compromised this, what they call the public key directory of the server where the data is stored there, then he can change whatever, he can forge any public key. So we can do better by using what we call different story. We're going to use public key authority here. Okay? So in this case, anyone who try to access the system, try to, let's say, register his or her public key is going to do this one in a secure way. And it looks like we have more details. And you can, get some information and you can confirm whether the public key is secure or they say public key belongs to the person who claims to be or not. Okay? So it requires the user, must know what's called the public key for the directory. Public key authenticate authority. I know what's the public key associated with this one. So in this case, as a user this is my public key A, and this is my private key A. For B is going to be this my public key A, B, and this is my private key P. And here for the authority, of course, we have the private key of, to say, the authority. I will use AU, and you have the public key of the authority, AUT. Yeah, in order to make sure that we distinguish between this and A. Everyone must know the public key of the authority. Then, when you try to, and you have securely register your public key there. So when you establish or register your key, we're going to send maybe encrypt the information and send information to the public key authority. Say, hi, this is me, my ID, and this is my public key. Okay? This is public key. This entry is going to be stored there. So anyone wants to get access to the public key, I need to, whatever, get this information, must be somehow, I'm confident when I receive whatever public key can tell me for sure this public key belongs to that user, no one else. So I'm going to send a request and say, okay, this is me. I want to communicate here in this case with B. And this is the timestamp. I'm sending this request right now. Okay? And the timestamp is going to be used as the nows. In order to do what? In order to authenticate who I'm communicate with, and at the same time, I can tell, or I can, make sure that I'm gonna avoid the reply attack. If you take a look to the previous one with the algorithm, that even when you get the information from what is called, the public key directory here, maybe someone else can intercept the communication, can switch or modify that public key with another public key, and you cannot tell the difference. But here we try to figure out a better way in order, once you receive the information, I'm confident to a certain degree that there's a public key that belongs to the public key, the user that I'm looking for. You got this one? So in this case, you send this information. The public key, take a look, you said, okay, I know this is Alice and Bob. Okay, Alice wanted to communicate with Bob. I'm gonna grab the public key of Alice. Okay. And I'm gonna, I'm gonna grab the public key of Bob, and I'm gonna add this one to the request and add the timestamp. Make sure this recently, and also I need to prove that I received the information and you communicate with the public key authority, and I'm going to sign it. Remember, when you perform public key encryption scheme and you use the private key in order to encrypt the message, that means you are going to sign this message. Why you sign this message? You need to confirm that and authenticate yourself. Yeah, this one option, of course, the data integrity, and you need to have like origin authenticity or authenticity of the origin, who the one that origin, or say, generates the message. You send it to the one that lock or Alice. Alice is gonna decrypt the information here, and you're gonna say, okay, I know the public key of the 30, so oh, I know this is the public key of B. Okay, this is request A and B, and I challenge the public key authority and reply with the timestamp or the nonce, whatever I use here, so I can tell I'm communicating with the public key authority, no one else. Then now I'm gonna send this information. Said, okay, hey Bob, this is me. I'm encrypt the message of the public key, Bob. I'm not gonna ask Bob to give me the public key. I'm gonna send the message or try to authenticate myself. I said, hi Bob, this is me. This is my nonce. Prove that you are Bob, no one else. So I encrypt this one, use the public key, Bob. Bob, once you receive this message, decrypted, they're gonna say, okay, Alice wanted to communicate with me. What's the public key of Alice? I don't know. Let's ask the public key authority. So you're gonna perform the same operation that 1 and 2 that has been done by Alice. Send request. This is me. I wanted to communicate with Bob, Alice, and this is my timestamp. Prove to me that you are the public key authority. At the same time, prove to me that you know my public key. And also, give me the public key of Alice. You check the information, retrieve the public key of Alice, because I know that Bob wanted to communicate with Alice, encrypt or sign it with a private key for the authority here. What the public key of Alice, request from Bob and Alice, and the timestamp to prove that identity and the person and the public key authority. Decrypt, I got the public key of Alice here for Bob. Then now I'm gonna reply to it. Bob challenged me, Alice challenged me with something. I need to reply to him, and also I'm gonna challenge him. I need to authenticate who I'm gonna communicate with, and prove that my identity is Bob. So I reply, public key of Alice, I received from the public key authority. I trust because I have authority, because it's encrypted with the private key of the authority. Send a nonce that I received from Alice to confirm that I'm Bob, and also into a challenge him. Alice is gonna do what? Decrypt the message with her public key, the private key, Then after that, you're gonna do what? Get the nonce, okay, is equal to the same nonce, send it to the Bob, okay, this is Bob. Oh, he challenged me. Let's do this one. I encrypt this one with the public key that I received. Now at this point, we have a confidence that Alice and Bob, both of them, they said, we do have the public key of each other. And we know exactly this public key that belongs to the other party. So now they can use this one in order to exchange the key, communication, whatever. Remember, the goal here is just in order to make sure how can we come up with a authentic channel in order to exchange the public key. Okay? Alice and Bob can store this information and can be used for a long time or for a specific time. But maybe after 1 or 2 days or 1 week, maybe you're gonna perform the operation again because maybe Alice and Bob or either party is gonna change his or her public key. So we need to have most updated version. Okay? So what's the certificate? It's like a different way or alternative approach allow us in order to use this, a new technique or new way in order to every single participant in the communication can exchange the keys without contacting the public key authority in real time. So what's the certificate? Certificate, I'm not gonna see piece of paper. So I assume that if you can measure that to try to find the similarity between the certificate of driver license, it looks like the certificate gonna bind what? Your identity with ID A and your public key, let's say public key of A. Okay, of course there's many information, but this is the main thing. It binds the ID or the identity of communication party with its public key. So anyone can use certificate. They say, oh, I can't. You can't send the certificate here. Then you can say this is me and this is my public key. Okay, so this one is going to be somehow signed by whom? By DMV of the driver license, or let's say by the authority, public key authority. We have a different names here in the system. It's going to be signed by the public key authority. Say encryption, the private for the authority. This is going to be signed. You cannot modify it. Then you can send your blank text, your ID and the public key authority. Your public key. So everyone can receive this certificate. They're going to say, okay, you said this is your ID and this is public key. Yeah. oh, there's a certificate. I can't verify the signature of this certificate. Okay, if you verify this one, you find this one valid, that means you can tell, oh yeah, that's right, your ID, and this is your public key. In other words, you're gonna find a way in order to bind the identity of the user with the public key. Okay, and this one again, it must be signed by trusted third party. Everyone's trusted the DMV, hopefully, yeah, because the one that's gonna generate your driver license. Anyway, so generally speaking, when you talk about the third party here, we are going to change or use different names. Instead, we said public key authority. We're going to call this one certificate authority, with the one who's going to issue this certificate. I'm going to go with the steps. How can we generate this certificate? Then after that, I'm going to show you how can we use that. Okay. By the way, who is the certificate authority? Who can be? I'm going to say any government agency, if you trust them. Not everyone. Telecommunication companies, or let's say antivirus companies, or the bank. You trust your bank because your information there, so your bank maybe can issue this certificate. I'm gonna show you, the top 10 list of the certificates in the whole world. You can see all of that. I'll give you a second. I think I have a link here. I want to share with you, so we can go over who can issue this certificate, who can be the certificate authority, who these guys can be. The major players of certificate authority, I guess the number one is going to be identity trust. Number two, digital certificate. Number four, I guess, GoDaddy, etc. These numbers are going to be changed with the time. So if you take a look to this link, it's a Wikipedia link. Okay, so we have, let's say, a set of entities available there, which allow us to know that we trust them, which is going to generate or create what's called the digital certificate. It's better to say digital certificate, okay? Which again, we can define it as electronic credentials used in order to what? Online, in order to assure, in order to prove your identity. Okay? Identity might be going to be whom? Individual, as a person, or the computer, or maybe as a website, or let's say in anything in the network. So again, it's similar to the ID or the driver license, okay, passport, whatever, which contains the public key and the identity of the owner. Who owns this public key? Of course, there is many information, we're going to see that, but this is the main component of the digital certificate. Who can issue this? We call this one the certificate authority. Okay? Of course, we do have another type of certificate. We're going to see that maybe you can use what is called self-signed certificate. You can sign it by yourself. Sometimes when you build our web application, I want to test my applications, okay? In order to get the certificate, you get, let's say, a real certificate, you have to pay money in order to get the certificate. And depends on, the requirement and what we need to, or how can we use the certificate, that means it depends on the price. The price is going to be changed. Sometimes I don't want to do this one. I just want to test my system so we can build the self-signed certificate, which is the one I'm going to do it in the lab today, just a short demo. Which allow you in order to test your system and etc. Oh, great. So I will check this one, but generally speaking, the fee, that means maybe prove your identity, the owner of this website. But we need to make sure that we need maybe to add more, let's say, requirement or constraint in your identity. I'm going to go over this one. I think I need to summarize this one in one slide, or say external tutorial just to go over this one. Give me a second. I think I have one slide here. I can go over this one in order to show you that there are many options. Yeah, maybe you can use a free one, but free one just prove your identity. You are the person who claims to be, but cannot guarantee that, for example, they didn't go over this thorough investigation to confirm your identity 100%. Yeah, you cannot do or confirm the encryption scheme that you use in your system and etc. Okay? For example, the certificate used by IIT definitely is not going to be free. Yeah, because you need, by the way, to let's say certify. Your main domain, then all the subdirectory that's stored in your domain, and etc. I guess in the IT, not all the subdomains are certified. Using secure HTTPS protocol. You see that, I know it's embarrassing. Sometimes if you check some websites that belongs to the computer science, you see that it's not secure. So it's gonna be funny. We are IT technology, and we do have an issue with this one. Anyway, I will get back to this one. No, I mean, yeah, exactly, yeah. And we are computer science. Don't tell anyone. So anyway, so it looks like I have a certificate. It's gonna be bind you a public key to say, yeah, don't tell anyone. Yeah. Anyway, so it's like say bind your identity to whatever this public key. This is the most important thing. Okay. So this is a certificate. So generally speaking, this is the kind of information that we need to do. That you need to have in your certificate. If you take a look here, you see that, for example, PUB is going to have or issue a certificate, looking for a certificate in order to prove his public key. So here, this many information, I'm not going to include all of them, but there's some of them. Here, the ID of the PUB, who are you? For example, IIT, and this is my domain, some information, email, some information is going to be stored there. Not all of them, okay? Then this is your public key. Of course, we're going to go in more details, show you the exact content. But the most important thing, we have the ID, this is PUB, and for example, the public key. And here we need to have some information about the certificate authority that signed this certificate. Then after that, we take all this information, okay? Then we need to hash them. All the information at the top. Hashing, then after that, I'm gonna sign the hash. And you know why you need to sign the hash value? Because the hashing is going to have a fixed length, a small length. So instead to hash, for example, or sign to say a lot of information, too many or a huge size, or let's say many blocks, then you're going to end up to sign small amount of data, 160 bits or more, plus minus. Sign them using what? The private key of the certificate authority. Then add this signature here of the signing into the bottom here. So the certificate is going to be, in this case, the PUB ID PUB, the public key of PUB, some information about the certificate authority. We're going to see them. One of them is going to be of course, when you sign something or using public encryption scheme, you have to tell me exactly what the encryption scheme that you use. Anyway, so this information is going to be plain, in the plain text. Then after that, I'm going to have, let's say, certificate. I will use certificate key, assigned. So here, those information can be stored together here in the certificate. Okay, when you send it to someone else, anyone is gonna take a look and say, okay, this is the certificate. Okay, that's what I received. And the certificate, as you say, the sidebar. This is the sidebar, for example. I can decrypt the signed one because I use the the private key of the certificate authority. If I decrypt this one, I can get this part, which in this case, the hash value of the whole information, right? So this one is going to be the hash value of the PUB. Let's say the ID of PUB, let's say the public key of PUB, and the certificate authority information, right? The rest of all this information are available here. So I can take them and compute the hash value. And then compare the hash value, make sure whether they're correct or what, whether they are matching or not. So again, you have plain text or part of the information can be available. Anyone can read it. You can modify them if you can, but we can easily detect that. Compute the hash value for all the public information here, or actually for the entire information that's including this certificate. Hash value, then sign the hash value of the plain text that we have, all the public information that we have. Then add this one to the certificate. Okay? When you sign, when you use a digital signature, you achieve many goals. The most important thing, the data integrity, and also you can confirm the identity, authenticity. Who did that one? The only one that has the private key of the certificate authority. I decrypt the signature, so this, or verify the signature that I'm trying to do here. When you decrypt this one, you are going to produce what? The hash value for the entire thing. So you reach this point. Then I can compute the hash value again based on the plain text or the information that's available in the certificate. Then I need to compare them. Here I'm going to verify. If they match, they say, okay. Then if they are matching, what I'm going to do here, so I'm going to say, yes, this is the public key PUB. That's why I'm going to use this one. I have confidence that 100% this is the public key PUB. If not, that means you are going to ignore this one and say it's not the right thing. Okay, it's not the right public key. One thing here else, we need to emphasize here, since we're going to use some hash algorithms here, we need to use use a public key encryption scheme, using some keys, etc. All this information can be included here. I'm going to show you the exact content of the certificate. All the hash algorithm can use, how can you tell what kind of hash algorithms? All the information can be part of the certificate, the plain text. Everyone can see it. What kind of, let's say, public key encryption scheme I'm going to use? What here? What kind of parameter? For example, use RSA. I need the value of n. I need the value of p. I mean the e, and etc. All the information can be available here. Okay, which allow you in order to do your job. We are going to get back to this one later. So the certificate in general is going to bind the public key, the ID of the user, with the digital signature of the public key of, let's say, of the ID of the user, and let's say all the plain text or all the information in the certificate in general. So if you take a look, the certificate of Alice can be what? Public key, I'm going to use what? The ID of Alice contains the public key of the Alice in plain text, and more information. We don't care right now. We're going to visit this one later. Then we have a signature of what? All this information can be here, and the certificate must be signed. Why you need to sign this? Anyone can, for example, try to change the public key of Alice to something else. You can discover this one. You can't tell. Even change the ID of Alice someone else, since you cannot change the signature of the signed part here, because it's signed with the private key of the certificate authority, unless you have the, access to this private key. Okay? So let's take it. How can we get this one? How can we get these certificates? How can you generate this one? Alice is going to do what? Generate, let's say, public key and the private key, send the request. I said, this is my public key, this is my identity, please generate one of them for me. So the certificate authority is going to go over many steps. Okay, first of all, we're going to verify the ID, whether are the real identity or not. And here it depends what type of, let's say, certificate you need to fill. If you want to just for your domain or your identity, maybe they have list restriction. Maybe they're going to send you an email and say, please confirm this email, then they connect. Let's say, verify your identity. If you require more, let's say, a strict version of the certificate, in this case, they're going to go with many, let's say, thoroughly investigation. Make sure that you are the person that he claims to be. Send you email, call you, maybe you have to come in person, maybe you send more supported documents, add, etc. Okay? Anyway, once you verify the identity, they're going to do what? Take the ID that you provide us, okay, with the public key, with the ID, then you have to sign with the certificate authority, private key, then add this one to the certificate. If you take a look at the certificate here, you're going to have the public key of A and the ID of A, then many information then, and the bottom, the signed part with the SA. And this is the information. When you communicate with anyone, you have to send the certificate. So instead you publish your public key, send this one. So anyone can verify this one, you can tell whether your public key is the right one, this is correct or not. Okay? There's something, sometimes you need to generate your public key and the private key and delegate all the job or propagate all the computation at the certificate authority. This is me, please generate your private key, public key, and give me certificate at the same time. So that's what you're gonna do here. Okay? So now, remember the Diffie-Hellman key exchange? We have a problem with the man-in-middle attack. User certificate is gonna eliminate the effect of the man-in-middle attack. So how can you do that? We have Alice and Bob. We're going to generate, to say, the private key. Then after that, they generate, they say, the public key. I'm not going to send alpha of A here and alpha of B here. No. What I'm going to do here, of course, I need to have a certificate. And we're going to see the certificate can have many information. The most important thing, the certificate contains what? Your public key, the public key of Alice, the ID of Alice, then the signature of the public key and the ID of Alice, signed by the certificate authority. So this is, I'm going to send this information to the Bob, and Bob is going to send me the certificate P, which contains the same information based on the P of the Bob information. So when you get this information, the first thing you're going to do here, the certificate contains many pieces of information, A, ID A, and the sign of A. This is the simple version, okay? So what we're going to do here, you can compute the hash value for A, to say hash for A and the ID of A. Then you decrypt the signature. So here you're going to get, for example, the hash value of A and ID A, then compare them. If they are matched, then yes, I can use this is the public key of this is ID of A, and this is the corresponding public key of A. I have a company with it. Okay? And the same thing, Bob, Alice good the same information. Then use the public key raise to your private key, and Alice is gonna raise, the public key receives from Bob, to the A. How about someone try to intercept the communication? See what we can do here. Can Oscar try to intercept the communication? Oscar's here. I'm gonna say, okay, I'm gonna send certificate Oscar. This is the only thing that you can do here. This is a simple thing. Substitute this one with different certificate. When you send this information here, certificate of Oscar here, with both sides, here it's gonna be fail. Because it's gonna say, for example, I wanna communicate with Alice, for example, and we exchange Alice with Alice, but the certificate is Oscar, so someone else in this case, not Alice. So I know that I'm communicating with, they say, Oscar. And this is the public key of Oscar. You can reject this one. Someone has said, okay, how about, I know the certificate A contains many parts. How about I'm gonna change one of them? You see the ID of A, I modified to the ID of Oscar, okay? And the rest, and this is the public key of Oscar. Can you change the signature? No, I can't, because I don't have the, what is called, the private key of the certificate authority in order to do that. When you send this information, here it's gonna be failed. Why? Because it's gonna compute the, let's say, decrypt using the public key of the certificate authority of the SA. Okay, so it's gonna hash the ID of A and to say the public key of A. Here, I do hashing for the ID of O, where this the public key of O. Remember, it depends on the hash function. Hopefully, you cannot easily find the collision. So this both. In this case, the both hash value doesn't match. So this is completely solve the problem of the man-in-the-middle attack. Okay? So for the certificate, what we need to achieve here? We need mainly, we wanted to achieve that when you receive this certificate, you can authenticate, or you can make sure whether the public key associated or included in this certificate belongs to the party it claims to be or not. So here, mainly authenticate or distribute the public key in most, I'm not gonna secure way, but in authentic channel. So certificate, you can tell, oh, when you send you my certificate, you can say, this is your public key. I can tell. And you can approve it. So if someone play around, you can tell, oh, you try to play around, you try to trick me, you try to impersonate, for example, Yusuf. You are not Yusuf, you are someone else. It's not better public key handling. We do have a problem. Any public key encryption scheme, we talked about this one last time, any public key encryption scheme are vulnerable to man-in-the-middle attack. Why? Because the public key is not authentic. So for example, A and B, I said, hey, this is my public key. And this guy say, hey, this is my public key. Can you confirm, can you tell for 100%, can you trust that? No, I can't. Because anyone can intercept the communication in the middle here. I said, oh, this public key, I send the B, say, hey, this public key, this Alice, this is the public key of Alice, they change, modify this one. And at the same time, you're gonna say, hey, this is the public key of Alice. Instead, intercept the communication between Bob and Alice and substitute public key Bob to Alice. This is the problem with the man-middle attack. In order to solve that, we need to figure out a better way, or let's say an authentic way, in order to allow us, in order to distribute the public key. Public key must be public. That means you have to announce that somehow. We went over many methods, proposed methods. All of them, they have an issues. The best one was the one that used currently in the, let's say, web security. Mainly if you try to achieve HTTPS, which the one we're gonna go over this one in a few minutes, give you an example of how it works. That's in order to help me, in order to authenticate that, or make sure I have a certain degree of the confidence that when you receive the public key of someone, or an entity, or the computer, or website, or server, I can tell for sure that whether this one is the correct public key or not. This is the main thing. Hopefully that makes sense to you. So let's take a look at the certificate here. Someone has said, okay, we do have a problem here. Now, we try to solve the public key distribution, use the public key, somehow public key scheme. Yeah, of course, because we said we need to sign the message based on the certificate authority private key. Then everyone can do what? Can do or verify the signature. Using what? the public key of the certificate authority. So the question here, how could you distribute the public key of certificate authority? Do you hear that? How can you do this one? The nice thing here, mainly the certificate authority public key is going to be distributed at the time of the setup, time of the system. Or all the web browsers right now that we have here. No, if you append this one, it's already there, yes, but how can you make, let's say I give you this one, certificate, for example, A, that contains ID of A, signature of, let's say, public key of A, of course, the public key of this is certificate authority, and here, let's say, the signature A. But I need to make sure that when you receive this one is the certificate authority, public key of the certificate authority, because Oscar can fake certificate and substitute the public key of the authority with its own public key here. You can say public key of, let's say, Oscar. Okay, so Oscar can forge this certificate in this case, all right? Because he's gonna say, let's say Oscar. Let's do this one, public key of Oscar. Let's say I'm gonna say this ID of A, public key of Oscar. So anyone can check, oh, the A, this public key of Oscar, and I'm gonna sign this one, or let's say encrypt, using the private key of Oscar, of ID A, and the public key of Oscar, something like this. I can do this one forged. But we need to make sure that at the receiver side, they can confirm with this public key that belongs to the authority or not. You need to confirm. It doesn't mean that you receive a message, you're going to trust it. You somehow need to verify that. How can you do this one? So mainly, or the most, or all the web browser, it's going to be shipped with the public key of, let's say, many certificate authority, mainly for the root certificate authority. It's going to be there. So every time when you update your browser, etc., these set maybe those, the set of public key is going to be what? It's going to be, let's say, updated. So when website, we try to communicate and work with any server, he knows that what the, it looks like be loaded with a set of root certificate authority, public keys. It's going to be available. So I can use them in order to provide the signature. Okay? So we solved this problem. So let's take a look. How can we use a certificate? How it looks like in the real world. Right now, as you check the website, how can you tell whether the website is like secure or not? When you say secure, that means use SSL or TSL. In this case, you check in the left corner in the browse, you see the padlock here, and you check there is a lock, padlock here. If you click over this one, it's going to tell you, for example, what's let's say the certificate, whether it's valid or not. If you check the certificate, right now you can see mine, for the blackboard here, you see there's a trust here, and you see that the trust they use X509 policy. This, mainly, this is the main certificate that we're going to use, from the certificate. X509, which have the specific structure. It's going to have a subject name, it's going to have like issuer name, who they sent to create this issue, what's the public key information, and etc. Many details. And you're going to have like extension. This extension can be different. So Justin, you can check your, let's say, certificate and see what kind of, say, guarantee the certificate can offer, can achieve. And mainly take a look to the extension here to see whether it can be from encryption, decryption, etc. What kind of, let's say, signature algorithm used, and etc. Anyway, so here the main form, the most used form is what we call X509 certificate, which contains the following information. By the way, this is what we're using right now. IP security, secure socket layer is the old version, or right now we use all of us use transport layer security, with the way that how can, let's say, website or let's say browser or client authenticate or validate the public key. Or of course, this is the main thing, to validate the public key of the server, then establish session key, then now HTTPS protocol is going to be working. Every data is going to be encrypted, and etc. Okay, so the certificate actually looks like something like this. We do have many versions. Okay, those actually, the actual information then going to be stored in any certificate. So if you went to the whatever website you want to check, acceptcs.iit.edu, you're not going to find this one. Go with the bank account or whatever, or look website, etc. Go to the left corner, the browser, in the top and the left, and check the padlock here, and check whether it's the content of the X509. You're gonna find the following information. version. We have a version 1, version 2. Currently, we have a version 3. So we add some enhancements, some updates, adding more details, more functionality, more features. Okay? The first one, you're going to have the serial number. The second one, certificate serial number. It's like unique number. Okay? Within issuing certificate authority. By the way, we don't have only 5, 6, 7, 10 certificate authority. We have what we call a chain of certificate authority. So for example, maybe we have one certificate authority, A1. This one can be certified, a set of the certificate in this region, and this one certified by the higher level, certificate authority 1, which can have certificate authority 1 up to N. Then this one is going to have higher one until you reach the root, certificate authority root, which in this case, the list that I've sent it to you, maybe whatever, there's many, let's say, certificate authority, we can use them. It might be identity trust, it might be GoDaddy, and etc. Okay? We used to have a semantic, I don't remember the entire name, but the Google eliminate this one. So yeah, they don't trust, the Google browser doesn't trust anymore. The certificate issued by, I think, semantic. I don't remember the security, I don't remember the entire coming. Anyway, so keep it updating this list of the root. So you see, we have a root, and the root you have many, in lower level you have many certificate authority, which either them that maybe gonna certify the set of certificate authority, etc. Because if we have, for example, only certificate authority available in the world, the whole world, it's gonna be problem here, because it's gonna be bottleneck, because if we want to communicate with this certificate authority or this, let's say, issue certificate, etc., it's gonna be not good solution. Yeah. So in this case, each of them can have like a branch with, let's say, different levels or sub. Assume that we have a sub level, or say a branch of certificate authority. Each of them have maybe certify another certificate authority, and etc. So sometimes in your whatever certificate that you found in website, sometimes you're gonna find the link. For example, certificate authority 1, and the side one has certificate authority 2, certificate authority 3. So that means you're gonna check. If you check this one, the backlog, you're gonna see maybe you have like something like hierarchy, like this. So this means when you get the certificate of this website, it's gonna be certified by certificate authority 3. And this one you're gonna receive, actually you're gonna receive certificate 1 for the website, you say website. This is certificate iit.edu. Then you're gonna receive certificate C3 in order to confirm that this one certified by certificate authority 1. So certificate is say 3, and certificate 3 is gonna be certified by certificate 1. Yeah, and the certificate 1 assume this is the root. So in the web browser, the Google, Chrome, or whatever, you're gonna find that the public key of the certificate authority 1 is available there. So I'm not gonna add all the public key for all the certificate authority, only for the roots. So each one will be somehow like, we call this one a chain of certificate. You start on the lower level until you reach root certificate authority. That root certificate authority, the public key is going to be available in your browser. It's going to be preloaded there. So this one, I can use the public key of certificate authority 1 in order to check this, authenticate to provide the signature of certificate authority 2. Then I can use this one, after I provide this one, take the public key here in order to provide, the signature of the certificate of this issued by certificate authority 3, certificate authority 2 to the certificate authority 3. Then after I verify this one, I can use the public key in order to verify the certificate issue for this server. That's what actually is gonna happen here. Make sense to you guys? Not at all. Okay. So again, let's take a look at the content here. I'm gonna go back here and go over this one a little bit. You need to, the most important thing you need just to understand what's going on. At least you're familiar with the content here. The first one, certificate serial number. This is a number, whether it is unique within the issuing certificate authority, whether it's gonna be, assuming in this case, certificate authority 3, okay, was certified. This one gonna be uniquely identify any certificate issued by this guy. Then here, since we're gonna sign, I'm going to sign something here. Certificate. You have to tell me what the algorithm used in order to sign this. Let's say certificate. You use the public key encryption scheme. So what's the public key? So give me what the algorithms and what the parameters here. Of course, what the value of use RSA, that means what the value of N, what the value of public key use here, which E. And etc. Many brands, it's going to be listed here because I need this information. All right? Who issued that? What's the certificate authority that did that? Here you can check whatever certificate authority, issue the certificate that used, for example, with the IIT, not the computer science. Then after that, there's a validation. This one is going to be like a period of validity. I can tell, for example, mainly it's going to be 2 dates. You cannot use this one before, and you cannot use this one after. I think last year was, the certificate authority of the certificate that issued by the IT was invalid. So if it was invalid, the system going to say, hey, we cannot trust this one. If you want to proceed, that's your problem. It looks something like this. I can't help. What's going to happen that it's out of my control. I cannot guarantee the communication. I cannot guarantee that you communicate with the right person. I cannot guarantee the data will be encrypted. Okay? So not before, not after. You can check, I think the IT maybe up to 2022 now or whatever. The subject name. I issue the certificate to whom? Now I need to bind the identity information with ID A or B or whatever. So in this case, hopefully it's going to be IIT or Alice or Bob. So here you have many details, many informations, okay, about this one, okay? Then now, what's your public key? My public key, this is information public key. What's the algorithm used in order to generate this public key? Now we have to do, for example, RSA, then RSA, you give me the parameter that you have, the value of N, the value of E, then the key itself. And you can see the key itself if you check the certificate here, okay? Then now, issue unique identifier. You have a unique ID, yeah, with like optional, just to make sure that's going to be unique within the certificate authority. Sometimes the certificate authority maybe use the same certificate serial number for multiple, let's say, identities. So I'm going to use this one in order to uniquely identify this certificate. Okay, and you have maybe some extension you add here. You have some facility you can add them here. Okay, for example, actually mainly adding the version 3. Then here, this is the nice thing. Remember we said all this information can be available. You can see them. And also you can modify them if you want. But remember, all this information can be what? It's going to be hashing. Then after that, it's going to be signed. And it's going to be stored here. Signed by what? What's the signature algorithm that you use in order to hash and sign this information? So you have to tell me exactly what's going on. All this information here, it looks like I'm going to repeat this information that the signature algorithm here. Then after that, I'm going to have the encrypted hash value here. It's going to be part here. Someone will say, why you need to repeat, the public or the encryption scheme or the signature algorithm that you use here on both sides? Just for security reasons. If someone modify this one, here just double check. You can't give you the actual one because you have to sign the whole thing. What I'm going to sign, remember, I'm going to encrypt to say, let's say the private key of the certificate authority of what? Of the algorithm, of the parameter, and also the hash value here. The whole thing that we need to sign them. Okay? Which is going to be encrypted hashing. Yeah, you have to sign the whole thing here. So this information can be signed here. Clear? That's the idea how it looks like, what's the content here. How can you obtain this one? As I mentioned here, you have to reach out to the certificate authority. Okay? And when you reach out to the certificate authority, definitely you're going to tell, for example, you have to send a request. We call this one like, I think, let me check here. Certificate signing request, which contain your information that you send it to the whatever certificate authority. Then this certificate signing request is like encoded text file that contains your public key and other information about you. For example, this is me, this is my email, this is my contact information. If you want to confirm, you need to validate because the certificate authority wants to do what? Wants to do, verify the identity of the one that asked for in order to issue the certificate. So give me more details, more information about you. Then give me email, I will reply to your email or send you email. Give me phone number, address, etc. Physical address, maybe send someone there in order to visit you, or we have to prove, or send me maybe, let's say, supported document in order to help me in order to identify your identity here. Okay? So generally speaking, the certificate that we have, it's going to provide, let's say, many things. One of them, authentication, which by serving as credential to validate the identity of the entity that is issued to. Authenticate that you to say what is called, your public key. And also can use for the encryption. Because now we know the public key encryption scheme that you use here, because it's listed there. We can use this one in order to help us in order to share or establish session key, or let's say in order to distribute the master key, if you want. And also it's going to provide integrity of the document here. So anyone, if you try to change any, let's say, alter any part of the certificate, we can't capture this one, or capture this one. That's what I said, multiple certificate authority with a chain of, let's say, certificate. You have maybe in the top here the root is going to be maybe sign a set of certificate authority, different levels here. So maybe in your case, the C or the say X with the entity that you reach in order to certify or to say issue certificate in your case. So as a C as an entity, it's going to get the certificate X and it's going to be its certificate for her. Assume that she, Alice. Okay? And the certificate X is going to be signed with a higher level, with W. And the certificate is going to be, then here I need the certificate W, which is signed by V, and the certificate V was signed by U, and the certificate U is with signed, for example, with the root, or one of the root. The chain of certificates, okay? If you're lucky, I'm not going to say lucky, but I think you cannot reach the root directly. So you have to go with the lower level. They distribute the job, the task in order to make sure that it's going to be the root, it's going to be available. So it's just going to validate the certificate that's issued by the lower level certificate. Okay? Certificate has a validation. So we assume that certification can be revoked somehow. For example, if you are not user anymore, or you are not the owner of this public key, or maybe your public key, somehow your private key that's associated with the public keys got compromised. So you need to do what? You need to delete, you need to issue a new one. So for the certificate authority, you're going to have like a list of all the certificates that has been revoked. Okay, of course, if the certificate is, expired because reach, the expiration date, it's fine. It's easy to check this one because any browser or any website can check this one and say, oh, it's expired, and then we can. The problem here, what if I wanted to revoke this certificate before the expiration date? Yeah? My private key is like compromised, or it happens many times with, I think, the semantic security. They used to be a certificate authority, but their private key is compromised. That means all the certificates issued by them, it's going to be invalid, must be revoked. And the Google, I guess, they said, okay, we don't trust you anymore, so any certificate issued by you is going to be rejected. It's not going to be valid. It's going to be displayed an error message and a warning message, and depends on the user. If they say continue, which we're going to talk about this one later, when you build this, you see the strongest security system in the whole world, but we have untrained user when this pop-up message said, okay, warning, you cannot proceed, the website is not certified, we cannot confirm the identity of the other website or public key or whatever, and say continue. Then you're going to destroy the whole thing. Anyway. So one thing I need to add here, we call the public key infrastructure. So it looks like when you work with the public key here, it's not enough to say this is my public key and this is a private key and you can work. No, we have something more. One of them is going to be what? The way that how can you generate the public key and the private key? And we have another component which is how can you certify the public key? So that's another, we need to have what's called the certificate authority. Then we have another component is called that certificate revocation list, where they have a list of all the certificates that has been revoked or have been revoked. All these components together allow me securely or safely, or to say, using the public key encryption scheme. We call this one the public key infrastructure. Okay? So that's all about this part. So today we're going to talk about something different. We're going to talk about the user authentication. What does that mean exactly here? In this case, we do have a user, and user tried to log into the system. The same thing if you try to log into your workstation or desktop or whatever, laptop, or try to log into the system. You need to find a way in order to prove your identity, right? So usually we try, if you remember that when you use the computers downstairs in the lab, in the IIT, you have to provide username and password. So this is one way in order to authenticate yourself, okay? So today we're gonna focus on how can users prove their identity to the program. The simple way to do that, to provide that user ID and the password. Then after that, we're gonna take a look whether there's another way, okay, better than the password for authentication in order to prove your identity to the system or to program or to a person or to anyone or any device in general. Okay, we're gonna see that there's many different ways. Mainly we're gonna focus on the password, okay, something that you know, okay, but we're gonna show you that we have other ways we can use them in order to provide the authentication for the user, okay? So first I'm gonna give you like a motivation, why you need to take a look to the user authentication, why the user authentication is important. So first I'm gonna go over a story of things going very wrong, okay? With the story, the case of Matt Holland. I know it's happened in 2012, but at least give an idea what's going on, why the user authentication is important. Then after that, we're gonna go over the user authentication more details. I'm gonna define this one again. Then after that, to give you like different ways, techniques, mechanisms you can follow in order to achieve this goal. Okay, we're gonna talk about the password-based authentication. This is a simple way that we know, traditional way. And then after that, we go over two different ways. One of them called token-based authentication, another one called biometric authentication. Then after that, we're gonna see that how the user can prove or say authenticate him or herself remotely. For example, you try to log into the service that's not next to you. You didn't have like direct access. For example, you're not gonna log into your own computer or desktop or ATM machine. You try to log in, for example, to access specific servers, which is gonna be like remotely located. So how can you exchange, for example, your authentication, whatever tokens, either going to be the password or the token based or the biometric confirmation through the internet, okay? Without the bad guy can intercept this communication, can use them in order to authenticate him or herself. So, as I mentioned, I'm going to take a look to the weak link, generally speaking. We talk about the case of Matt Holland. It happens in August 2012 for this guy. And to summarize that, how Apple and Amazon security flaws, okay, led to his epic hacking. So let's go over this story first. Then after that, we're gonna watch a short video on the YouTube. This guy is gonna tell us his story, what happened exactly to him. The first thing at 4:33, okay, p.m., Matt Holland called the Apple Care. So someone's here, hey, hello, that's me, I'm Matt, okay, and called the Apple Care. And asking that he lost his password to login access me.com. Me.com is similar to the iCloud.com, okay? It's the same account, just different aliases, okay? So, just request, hello, I forgot my password. And this guy somehow helped him in order to issue, let's say, temporary password. And the question here, how they give him the password. At that time, where the Apple, you only need to provide the following information. First, of course, if you try to report that you lost your password, generally speaking, the first way in order to retrieve your or recover your password or send you a temporary password, you need to answer, let's say, some security questions. Matt couldn't answer these kinds of questions at the time, okay? So the Apple required at that time the last 4 digits of the credit card and billing address. Those information are enough in order to reset your password account at the me.com at that time, okay? So you need to have only 4 credit, or as you say, the last 4 digits of the credit card and the billing address. So how Matt provides this kind of information? He managed to do that, okay? And we're gonna see how he got this information. So at the time, the one called, trying to impersonate this identity, called the Apple Care, said, okay, report my password, or lost my password. I couldn't answer the security questions, but here you go. I do have like the 4 digits of the credit card and the billing address. So they gave him the reset password. So now the Matt managed to can access to me.com account, okay? Or in other words, at cloud account, the email as a cloud account. At 4:50, this is the same 4:33, and at 4:50, okay, the password email arrived to the me.com email box. Then after that, used in order to reset the Apple ID password, because I managed to access one. Then after that, I can reset the Apple ID. Okay, password, good, because all of them are connected. Then after that, at 4:52, okay, Gmail password recovery email arrived to his account. So because he used this email, me.com, at me.com in order as temporary or alternative email or backup email for the Gmail account, and used in order to reset the Gmail. So now Matt can have access to the Gmail account, because now he got to reset password, then access, he can change the password in the Gmail. At 45, okay, Google account password change, yes, because you get the set password to the me.com account, and you use this one in order to access the Gmail. You see what happened right now. So it looks like Matt communicates somehow with Apple. Then, with Apple help them in order to reset his password in the Google. Yeah, so this is one entity, this is another entity. We need to answer the question here. How Matt got to say the last 4 digits of the credit card of his account, okay? And the billing address is okay, you can get this one, but the problem with the 4 digits. We can answer this question later. So that's what happened so far. Then after that, at 5 o'clock, okay, the iCloud find my tool used in order to wipe all the on an iPhone or an Apple or iMac or all the information. Then after that, at 5:02, now we got something, another, company gets involved, which in this case, Twitter, okay? Matt managed to change or set the Twitter password set. Then after that, all the information that Matt has been wiped out. The iPhone, Mac app, Poc, and all iCloud, all the pictures, image files, etc. has been deleted. So let's just before reach this point here, let's see what happened. So Matt managed to get to the Apple, me.com account, use this one in order to set Gmail, right? Account. So here the Google. Then use this one in order to reset the Twitter account. Okay, so it looks like Apple, Google, and you can say Twitter. Okay, at 5:10 p.m., the real Matt Holland calls Apple Care. Says, "What's going on? I cannot log into my account. All the information has been got lost." At 5:12, the hackers post message in his account, Holland account, Twitter account, taking credit for the hack, and this is the original message. This is a screenshot from that time. Okay, Clan, BB3, and Phobia hacked this Twitter. Okay, so the question that we try to answer here, how did it happen? Okay, actually it's based on the fail in order to authenticate the user. When someone called, pretended to be, say, Matt Holland, the Apple Care failed in order to say, make sure that this guy is the one he claims to be. Okay, to prove his identity. So, hacker generally speaking, what? Needs only the Holland Apple ID email address, billing address, and the last 4 digits of his credit card in order to perform the whole attack. But the question that we're still looking for, how these guys managed to obtain that sensitive information. I'm mainly talking about the 4 digits of the credit card, okay? This is the main thing here. So they start first doing some smart way here. First, they call Amazon. So now something new. We don't. So far, we didn't say anything about the Amazon. What happened so far? The Matt. Let's say here, Apple, Google, Twitter. This 1, 2, 3. Okay, and now we have Amazon. What they did here? These guys are smart. They call Amazon, okay, first, and they pretend that they are Matt Holland. And they need, for example, credit card with a Holland Amazon account, okay? How they did that, they first call Amazon and add a new credit card. So they just add a new card. They say credit card, a new one. They add it to the Amazon account. So now we have two different credit cards: the original one, credit card one, and the faked one, which added by that guy. At the time, how could you manage to do this one? By calling just Amazon. Then after that, you need just to provide the name, email, and the billing address, with enough information at that time in order to allow you in order to add the new credit card to the account. They hang up. Then after that, they call again, okay? And they said, okay, we want to set our password at the Amazon account. How can you achieve that? You need to prove your identity, yeah? So how they do that? You need to provide, say, the credit card numbers that Amazon at that time needs. So the guys, the bad guys, they are smart. What they did, they provide the credit card, they just, added the faked one. They use in order to reset the Amazon. Once you set the password for the Amazon, now they managed to log into the Amazon account and they got the information that they're looking for. Remember, they need the Apple ID, email address, billing address, and the last 4 digits of his credit card in order to reset the Apple account. So they got this one by tricking Amazon at the time. Okay? Once you get the Amazon, get this information that you're looking for, go to Amazon and do the whole thing that we cover or talk about this one. I like that, actually, the smart way. What they did, these guys managed to find the flaws in the security in different, companies here. Okay? What, for example, Apple consider very important information in order to allow you to set your password or prove your identity. Amazon think that is not, secure information. So once you log into the account, you can get the last 4 digits for your credit card. Okay? So what happened is the result? By taking advantage of the relaxed security policies at Apple and Amazon. Things change right now these days, but at that time, that's what happened actually. So hackers were able to breach, Matt's Twitter, Google, and iCloud accounts. They remotely wiped all the content stored in his iPhone, iPad, Mac Pro, remotely accessed because they have remote access to the data. Okay? Actually, he has some personal memories that he regrets that he doesn't have another copy. I think he has some pictures with his daughter when she was young at that time. Now he lost all these pictures. Okay? The problem with the Holland hasn't backed up his data. This is another problem. Okay? The question that we try to ask ourselves is why these guys did that? Why did they delete all this information from his device? They tried to prevent him to regain access to his account. That's the main thing here. Okay? Then after that, he got in touch with these guys, okay, with one of the hackers, and he tried to communicate with him, for example, why you did this one. And this guy said, I don't know. And it's not surprise for us, they are teenagers, okay? Which because I think he's 19 years old, another one maybe 20 or 21 years old. They did this one just for fun. Okay? So let's hear the story. Matt is going to tell us exactly what happened to him. And after that, we're going to continue our discussion. Okay? Give me a second. I want to share with you these slides. By the way, if you click over this link, you can watch this one later in your own time. It's interesting, at least, to hear from the guy what happened to him. And we try to learn. Then after that, we need to make sure that we need to come up with a better way in order to authenticate the user. Apple and Amazon learned their lesson, and of course they enhanced their security measurement at that in order to authenticate the user. Let us see this one. So what do you think? Interesting story, yeah? So just give an idea that very important, we need to figure out to find out better way in order to authenticate the user or the user authentication, okay? So let's define now the user authentication in general. The National Institute of Standard Technology defined the user, or they say the digital authentication as following, okay? Or the digital user authentication as following. The process of establishing confidence in the user identities that are presented electronically to an information system. Okay? So it looks like the process of verifying a claim that the system entity or the system resource has a certain attribute value. So user authentication, just speaking, is proving your identity to a system, or it might be to another person, whatever. Okay, and so it's like the process of verifying that the user is who he or she claims to be. So just speaking here, when you perform the user authentication, for example, you try to log into the system and say, for example, that's you, let's say Alice, and this is the system that you wanted to access. Say, hi, this is Alice. Prove it. Okay? Then you gotta say, here you go, this is my password. Check, you can say yes or no. Alright? And this is actually not what's gonna happen here. So you're gonna send somehow your ID. Then after that, the system asks you to prove that your identity. Then you're gonna give me the password. The same thing if you check with the Apple, etc., or the Amazon, in order to check or use it for user verification at that time, you just provide the 4 digits, you say, for the last for the credit card, for example, for the Amazon, and for the Apple at the time, you used to have only the last 4 digits for the credit card in order, of course, with billing information and etc. The Apple ID in order to prove your identity. Okay, so how can you perform this one? Actually, in order to achieve user authentication, okay, it's gonna be like 2 steps. Okay, first you need to perform what's called identification steps. This means you need to register with the system in order to store, for example, when you log into the system or you create your account. At that time, you're gonna, let's say, collect some credential information. For example, you get your ID. Then after that, you are going to choose your way in order to identify yourself. Generally speaking, mainly going to be about the password. Okay, this information can be stored at, say, the server or the system you try to log in. Then after that, you're going to perform the verification step. The verification step in this time allow only the authorized user to access the system by providing the credential, or let's say specific credential. Okay, so after you register for the system, so every time when you try to get the system is going to perform verification. And the verification, this is the process that involves that you have to give me specific information that in order to convince me that you are the person he claims to be. Okay, generally speaking, the user authentication is what? Is a primary line of defense in the computer security. Other security controls rely on the user authentication. It's very important. Mainly when you perform the user authentication, when you log in, manage somehow to convince the system that you are the person he claims to be, then there is something else after that. After that, the system is going to see you check whether you are allowed to perform this operation or not. For example, you try to log in, let's say, you use the printer, for example, the printer server on the IIT, okay? You log into the system, for example, desktop or whatever, any computer, provide username and password. Then after that, we're going to try to do specific tasks. For example, either we're going to delete all the files in the system, or you try to use the printer, etc. So now the system is going to use your ID. After they know that you are the person, 100% sure that you are the person he claims to be. Now I want to see whether you are allowed to perform this task or not. This is the next step. We call this one the access control. We're going to talk about this one next lecture. But right now you see that the first step, I need to authenticate the user authentication. Then after that, I use the information, whatever the result of this user authentication, in order to help me, in order to be able to say, in order to perform another security control. So mainly we're going to rely on the user authentication in order to perform another security task. So this is very important here. So to summarize again, so the user authentication, as we mentioned, is the security process that cover all the human to computer interaction or computer to computer interaction with your computer. Let's say you're going to use you're going to use a client program at your side in order to perform this authentication on behalf of you. Okay, we're going to see this one later when we talk about the CRUBs more details. So anyway, so this is all the process, okay, security process that covers all the human to computer interaction that require the user to register and log in here. Okay, so authentication asks each user, who are you? And verifies their response. Every time, who are you? I'm the person, okay, give me the proof. This is my proof, then I need to verify this one. Either I'm going to allow you to access or not. So just speaking, as I mentioned, 2 steps. The first one, you need to register with the system. You need to create an account. Otherwise, I cannot allow you to access, yeah? Because how could you prove your identity? Somehow you need to register with the system. When you use, for example, Facebook, we use, say, Apple or whatever account, or iCloud or whatever, you need to register with the system, okay? For example, you try to use any service in the IIT, you automatically register with the system, because when you enroll in IIT, the IIT department is gonna create an account under your name. So it's gonna perform the registration step, okay, on behalf of you. Then after that, that's user registration account. Let's go back to the register. When you use a register for an account, the user must create, say, a unique ID, which the value mainly gonna be user ID. It might be the email address, for example, etc. Okay, this one is a unique. It's not, doesn't need to be secure, but must be gonna be unique in the system. Okay, which allow the user in order to access his or her account later on. So username and password, this is generally speaking, this is, the way, or the traditional way used in order to identify the user. So when you create a user ID, you're gonna provide or create a password. Sometimes we call this one a key, okay? And when you say a key, here it might be password, it might be something else, as we're gonna see, okay? So in the verification step here, once you register the system, okay, the user, here in this case, this step is going to provide the users, say, repeat access to his account. So of course, when you log into this, right now, for example, you log into the Blackboard. Did you register? No, you already registered, okay? So every time you're going to repeatedly access the password, as long as you're going to provide username and password of the correct user or credential information in the system, okay? Which allow only you to access to your account, nothing else. So you cannot access another people or another student account. Why? This is what is called now after that the access control. So look, once you log into the system, to the Blackboard, you're going to see that you have limited access. You're going to see only the courses that you register for. And at the same time, you're going to see that you cannot do some tasks, for example, which if you check or figure out or find out your grades for the midterm exam, you cannot change this one. You are only allowed to view only your information, nothing else. That's what's called the access control. And based on what? Based on your ID. When you log into the system and the system successfully verify your identity, now we're going to take a look at the next step with security control, which is going to see or control what you can do in the system once you log into the system. Okay? So we do, in order to, for the user, in order to confirm their identity, okay? The user must provide, say, piece of information as I mentioned, okay? Which is going to be only the user and the server knows, which is, for example, the password, right? You know this information, and somehow this information can be stored at the server side. For example, at the IT department, maybe you have like unique, or to say, one place that store all the password of the user, okay? When you log into the My IIT portal, or IT portal, the system going to check the database against username and password. If you are allowed to access the system, going to say, oh, authenticated, then you can log into the system. If not, if you provide the password, wrong password, then the system going to kick you out. At least it'll give you maybe three tries to try to log into the system. Then after that, you're going to reject or stop, maybe block your access to this account. We're going to talk about this one during today's lecture, how the database, or to say the password will be stored, etc. Okay, so anyway, we said that in order to provide some piece of information, right, in order to prove your identity, which is known by the user and the server, okay, this information is called, generally speaking, the authentication factor, or it might be called the key. And we do have 4 different types of the authentication factor. The first one, or the simple one, the one that we know, yeah, which is something the individual knows. We call this one knowledge-based or the password-based. In this case, mainly we're gonna have like what? We're gonna mainly focus on using, for example, use the password, might need the PIN, or maybe you're gonna answer to the prearranged set of questions. All of them that you need to prove to the server that you have this kind of knowledge. Yeah, this username. Please give me the password. This is my password. Please answer the following question. I'm gonna provide you with the answer to the following question in order to prove my identity. Okay, so I need to prove to the system that I know this kind of information. There's something else, or another way in order to authenticate the user, use as authentication factor or key here, something the individual possesses. Okay, so in this case, you have to have physically, for example, maybe can I say, I do have a key, for example, or I do have like a smart card or physical key in order to log in or access the system. And you're gonna see some, you know that, if you still remember that in IT at the 5 o'clock p.m., all the doors are gonna be locked, okay? Without scanning your card, you cannot log into the system. Or the doors are gonna be straight locked, yeah? So in this case, you have just to scan your ID in order to allow you to log into the system. That's what is called something that you possess, okay? And this is the proof that if you scan this one, the system will say, oh, log in. Or you try to log in, for example, I try to log into my office. I cannot log into my office without a physical key, which allow me in order to log into the office. The other thing we can use as authentication factor is something the individual is, or we can say something the individual does, okay? So in this case, something the individual is, which is going to be static biometric, and does dynamic biometric, okay? So for example, something that the individual is, that means we can, for example, the fingerprint or your face, okay? Information, something get like based on the pattern, yeah. Similarly, the pattern, looking for the fingerprint, for example, maybe you have like at least 15 maybe points. In this case, we can say we have a certain degree that this is you are, no one else, okay? Something individual does, for example, maybe the system, in order to allow you to log into the system, you have to speak or tell or say, let's say, specific phrase. And the system gonna double check or make sure that whether based on your voice pattern, whether it's gonna be you or the person claims to be or not. Or maybe the handwriting characters, okay, and etc. So these are different ways in order to authenticate the user. We're still using the something or let's say something the individual knows. Well, mainly we're going to use the password. Although the password is not secure, the password is easy to hack, the password is easy to guess, but it's still so popular, okay? And we're going to see why people are still using that. And we're going to just give you an idea how can you use, for example, something individual possess and also something the individual is and does. Okay, just to give you an idea. I'm not going to go deeper, and mainly I'm going to focus on something the individual knows. One thing you need to add here, this information or this, let's say, authentication factor can be used alone, but or combined. For example, you can, when you try to log in, let's say, to the IT, let's say, or the computer science department, maybe in the future, we have like a restricted area, so you have to provide username and password or PIN. Then after that, you have to scan your fingerprint. Okay, give you a fingerprint in order to authenticate the user. Or maybe you're gonna send using username and password, try to log into the system. Then after that, I'm gonna send the code to your phone. You have to type this code within 10 minutes in order to allow you to log in to access the system. That's what is called the multi-factor, okay? All of them are gonna have an issues, okay? All provide user authentication, but they have some issues associated with it. This is just a quick example about the multi-factor authentication. So in this case, we're gonna use more than one factor together, okay? Or authentication factor or key in order to provide the user authentication, okay? The simple thing is the two factors that you are familiar with, okay? You can provide, for example, password, and also you can send you code to your phone, or maybe after username and password, then after that you have to plug USB, and USB is gonna perform the second authentication step. Or you have to scan your card, and after that you have to scan your fingerprint. Okay, for example, the left index or whatever. The credit card maybe you have with the signature, or maybe you have a card with the say PIN. We have two-factor authentication. You have something physical you have possessed, and at the same time you have to give me like another thing, okay? Something you have does in this case. And the figure is going to show us the steps here. We assume that we have two authentication factors. As a client, you need first to pass the first factor. Then after that, you need to pass the second factor in order to allow you in order to access the system. Here in the step here, now we know, for example, you provide the ID is Alice, and whatever the password. Here maybe you have code, or maybe another piece of information in order to send to your phone, in order to, authenticate the user. Then after that, now the system is going to say, this is the ID. Okay, clear. I know the ID here. This is ID is Alice. This ID is going to be used in the next step with another security control. We can use the ID, the access control, in order to check, for example, what Alice can do here. And now I have a comment that the ID is correct, is authentic, as is correct, is valid ID, and this is Alice. Now check what Alice can do. Alice can delete, for example, X file 1 up to file 10. Alice can, for example, read. Alice can delete, for example, the files 1 and files 5, for example. Alice can perform this kind of information, or Alice is going to be super user in the system, and etc. Okay. At the same time, we can use the ID in order to perform what's called discretionary access control. So we can say, for example, Alice has, let's say, own file, say 15. Okay, I'm just give you a files as easy example. Okay, then Alice is gonna say, okay, I can give X to the list or the set of users the following ID, but for example, Oscar can access my file, can read only my file. For example, give you like permission to access my files. Based on what? Based on the ID that for the user that we provide to get for the authentication step. We're going to talk about this one, access control, as I mentioned next time, next lecture. But right now, just keep in your mind when you perform the user authentication, we can use the information that got, or the, let's say, the confidence, okay, that we got that this is the user who claims to be, in order to allow us, in order to provide what the user can do, what the privilege access to this user based this ID. Okay, so again, let's going to take a look at the password-based authentication, more details, and we're going to see that here why the password is so, let's say, popular. Okay, and we're going to see, as you know, that is there is any better than or anything better than the password authentication. Actually, we said we do have a different ways, but we're going to see why still people mainly using the password here. So the password is, as I mentioned, a widely used line of defense against intruder. Okay. And generally speaking, the user is going to provide, let's say, login information, might be unique ID, of course, after you register in the system. Then after that, the password. Okay. So the system is going to say, for example, when you register for the system, assume that you're going to say, this is the ID and this is the password to every single user. Of course, we are not going to store the password, the plain text. We're going to see later a few details, a few slides later, we're going to see how can we store the password. But right now, just to keep you in mind, okay, we do have the user ID. Well, then we're going to have the associated with the password going to be stored in the system. Okay. So the system is going to compare the password with one stored in the specific login, for that specific login. So this information, let's say I'm going to call the password file the text, for example. And when the user, for example, ID provide username and password, for example here, the system is going to check, okay, this is the ID, and you try to grab the password and compare the password that provide with the user with the one stored in the system. If they are matched, then the system, the access will be granted. Otherwise, it will be rejected or denied. Okay? As I mentioned, the password is going to be served in order to authenticate the ID. This is the way, how do you prove your identity? How to make the system going to be confident 100% you are the person claimed to be. Okay? Of course, someone is going to say, okay, what if someone is stealing my password? This is a different story. Of course, if anyone knows your password, we can't do anything. Yeah, no, everyone knows your password, so they're going to all your information, then how could we help with this case? I mean, how could you tell that you are someone else? I mean, you're impersonating the user. You are not the real user. You can't do anything in this case. Okay? So anyway, the password, as I mentioned, is going to help in order to authenticate the ID of the individual once you log into the system. After you log into the system, remember what we did in the previous slide when we talk about the multi-factor authentication. We said after the user authentication, this one is going to be like a building block of the main building block for many security protocol mechanisms or technical controls. Okay, for example, the access control. So we're going to rely on the ID. Right now, after this step, now we're going to use the ID in order to help me, in order to build the next security protocol or control. Okay, so the ID user is going to provide security in different ways. The first one, determine, as you mentioned, what the user can do, what the access, right? Read, write, delete, whether you are super user or let's say normal users, etc. And also determine the user privilege, as you mentioned here, which is going to be the authorized to access the system. Of course, both of them, we're going to talk about the access control. Sometimes we're going to talk about the authorization as access control. Sometimes we call them, they have the same meaning, okay? We use them interchangeably. I'm gonna cover this one in more details next lecture. But right now, you can think about them that the same thing they try to achieve, the same goal. Whether you are authorized to access the system and what you can do once you access the system. Okay? So used in discretionary access control, this, as I mentioned, remember that you might be your own file, or create your files, set of files. Then based on the ID that you have of the others, you can use the IDs of the other users in order to tell the system will provide them with access right to your files. For example, I can create my files and share this file with all the students in this class. Yeah, that's based on what? I'm gonna use your IDs, which gonna be once you log into the system. Okay, each of you is gonna have unique ID, right? Which is used in order to log into the Blackboard, the MyIT portal, etc. When they give you the access right here with the files here, and this is actually what they're doing for the Blackboard. They're using your ID in order to identify whether you can access, the content of this class or not. And once you access the content of this class, it depends on your, let's say, role in the system. For example, if you are TA, then the TA can have more access right. The TA can do more, let's say, privilege. It can modify the files. It can, for example, change the grades, and etc. For the student, he has access only his or her, let's say, file sources. Okay? Makes sense so far. Okay. These many things act as the passwords. Okay? The simple thing will be the PIN. Okay? Or social security number. Please don't use this one as the password. Mother maiden name, please don't do this one, because remember, people are going to do social engineering. We're going to try to cover this one when we talk about the malicious software later in this class. Date of birth and name of your pet. Yeah, you can use them as a password, but please don't use them for the securities. Because the first thing I try to do here, I'm trying to figure out to find out your social security number. I will try to collect some information about you first. For example, your first name, middle name, last name, your mother maiden name, and etc. Your date of birth and name of your pet. And for this information, thanks to the social, websites, okay, Facebook, Twitter, etc. You're gonna find all the information that you're looking for. So it's easy to get most of the information here. So please don't use them, because this is the first. You'll try someone to try to guess your password. This is the first one. The first thing they try to collect information about you. Then after that, use this information somehow. Hopefully, one of them is gonna give us access to your system. Okay. So still saying here, why the password so popular? We didn't answer this question. Because it's what? It's the initial choice with authentication. Right now, when you log in to create an account, the simple thing, or most of 90, or actually all of them, provide you to what? Give me the username, create username, or etc. Then create the password. This is the traditional way in order to log in, in order to authenticate the user. Okay? Why? Because it's free. We didn't pay anything. For example, the only thing I require from the user to memorize his or her password to log into the system. Right? I don't need to buy, let's say, a special device which will allow the user in order to type his or her password. For example, for the use credit cards, or let's say smart tokens, you're going to see later that smart cards, you have to do what? You have to give me the reader device, which must be installed at the front of every single door in order to allow the user in order to scan their cards. Yeah? That's expensive a little bit. Okay? We cannot do this one because it's going to require for me to have many hardware that's going to be installed. What's for the password? That costs nothing. All I need, of course, you have to use a computer to look in your data, your phone, etc. And you need just to memorize your password or types. And it's convenient. Okay? For the user, the only thing you require from you to come up with the password, then memorize it. Okay? For the management tool, it's easy. Why? Because if you lost your password, the administrator of the system, IT admin, okay, do what? It's going to reset your password, of course, after you answer some few security questions. So it's easy, convenient for both of them. If, for example, compare this one using credit card, or let's say you have USB or key, physical key to log in, authenticate the user, or log into the system. So this case, you have like overhead, okay? Because now for the admin or whatever, the personnel, or IT personnel or whatever, the one that you're gonna acquire, responsible to issue your credit card, etc., require from you to cancel that card, ask, or say, create a new card, produce a new card, then send it via email to you in order to reach you can, for the user to use a new card or issue a new card or substitute card or replacement. So this is going to be costly. It's not convenient actually in general. So for this reason, because it's convenient and costs nothing, it's worthwhile to study the user password in more details. Okay, because it's still super, we're still used. So let's take a look at the password. Why this? I mean, and first see what kind of attacks associate with this password. How can you mitigate this kind of attacks? Then after that, we're going to see how can we store this password in the system. And this, we're going to see we have a different ways in order to store the password. I'm going to show you the best way, at least so far, in order to store the password. Of course, we're going to show you different ways. How can the people, the bad guy, try to guess your password? Okay. The first thing here, take a look, as you mentioned, let's take a look at what the vulnerability associated with the password. Okay. We do have a variation of the attack, okay, for the popular password in general. Those are the popular password attacks. The first one, offline dictionary attack. What does that mean here? Remember, we said we do have a file, and this file is going to contain, for example, the username, ID, and the password. Assume something like this. Okay, the structure is not important right now, okay? Of course, we are not going to, as you mentioned, store the password in plain text, but assume this is the password file. Store in the system. In the online or offline attack, what you're going to perform in this case, there is no real interaction with it. I mean, during this kind of attack, I don't need to require to connect to your system. The only thing that I need to get access to your files, and somehow the password file is going to be available to me. Okay, so in this case, the bad guy obtains the system password file. You can get the system password file, the ID and the password is stored in your local machine or whatever. Then now, disconnect from the server or that's the system they're trying to attack and try to figure out the way in order to say, find out the passwords. Okay? So in this case, generally speaking, the password is going to be stored in the hash function. I'm not going to store the password. I'm going to store the hash value of the password. Okay? So I do have the password, the username, for example, Alice, and the hash value, for example, X, Y, Z, 5, 6, depends on the size, whatever hash function that we're going to use. We're going to talk about this one later in more details. Okay? So in this case, I need to figure out the password of every single user. That's what I'm planning to do here. So we'll come up with what here? So we're going to compare the password hashed against the hashes of the commonly used password. I do have the file that's going to have the commonly used password. For example, the 1,000 or 1 million, or say 100,000 commonly used password in the United States. And you'll be surprised later during this class, you're going to see you still 1, 2, 3, 4, 5, 6. This is the top number one password in the United States. Yeah. Okay? So in this case, for example, assume that the password 1, 2, 3, 4, 5. For example, hello. Let's say password. Okay, I need to compute the hash value of each of them, then compare and find. If there is a match, they're gonna say, okay, Alice, the password, Alice is gonna be 1, 2, 3, 4. Hash the next one, hash of the password itself. Check whether find any match in this file. Okay, that's what's called offline dictionary attack. Okay, in order to countermeasure against this kind of or defeat this kind of attack, we need to have a control access to the database. Not every single user can access the password file in the system. Assume that once you log into the IT account, you're gonna manage to find the password for every single user. Everyone can access them. Then in this case, you can download this file, then try to perform this offline dictionary attack. But thanks, guys, we're going to do some kind of management, okay, control who can access what, so I can specify only the admin of the system can access this kind of information, not everyone. If that file has been lost or someone compromised the system, we need to reissue the new password of every single compromised for every single one. And also, we are not going to store the password only in the plain text. As I mentioned, we're going to store the password here, the hash value of the password, and complicate this one a little bit. We can add a salt. We're going to talk about this one, like a random number, or they say number of bits, 32 or 64 bits at least, in order to randomize the value of the password. I'm going to talk about this one. Or sometimes you're going to use a pepper, which is another technique, which make it harder to guess. Okay? In order to have a strong hash function and also salt. Okay? The second type of attack is called the specific account attack. So in this case, I'm going to target specific account. You assume that Alice or Bob, okay, or specific student, not me, don't target me, target one of you, okay, specific student here in this class, let's attack this guy. So we're gonna focus on this guy. So you see that the ID, I'm gonna say always, I'm gonna say Alice, and the password here, what I need to do here, I submit, the password guess. For example, I guess Alice, maybe the password gonna be June 22nd, 2021, for example. Or maybe gonna say password, or maybe 1, 2, 3, 4. So you try many times, okay, until you guess the password, okay? So the countermeasures that we're gonna see here, that's why if you try, some system require from you to do only 3 tries. If you fail, they're gonna lock the system for 24 hours. Or maybe you have to call, especially if in the banks, okay? They're not gonna lock the system for the minutes or 10 minutes. You have to call the front desk or whatever, the customer. They give you like specific phone number in order to call, in order to authenticate yourself, in order to unlock your account. So in this case, in order to prevent what's called the brute force attack, because what we're gonna do here, the simple kind of attack here, I'm gonna check. For example, the password policy specifies that the password must be, let's say, 8-character length. For example, only contains lowercase and uppercase. So total here is gonna be 8, okay? And each of them, the uppercase and lowercase, for example, 26 multiplied 2, yeah? This is the total number of keys, or let's say this one, or 26 raised to the power 8. Yeah, something like this, okay? That's the total number of, let's say, the characters that we can come up with. All of them gonna be A, and then after that Z, all the combinations of A capital and A to Z, and the lowercase and uppercase, all the combination between them. Okay, then you try to every single possible password, and then the system gonna say, okay, if you said 8 characters, you try all the 8 characters, then you're gonna find the password. But for the countermeasure, the system is not gonna allow you to try more than 3, for example, tries. If you fail, they're gonna lock that account, make it harder. Okay. So this is the specific account. The other thing, popular password attack. So in this case, this attack, I'm going to try the popular password. I'm not going to come up with all the password combination. I need to go have a list of the popular password is available online. I can use this one against all the users. For example, how many students do you have? Assume that we have 10 students in this class. I have a student 1 up to the student 10. I'm going to go to the file that contains all the popular password. For example, the 1000 popular password. I take the first one and try against the first user up to the 10. All of them. So again, the student ID S1 and the password, assume that the popular password 1, 2, 3, 4, 5, 6. The first one. For the user, first one, the user with the second user, up to all the users. Then take the next password, possible password, and try against every single account. Okay? Until hopefully, if the user then use the popular password, then hopefully one of them is going to be managed to log in at least one account here. The countermeasure again here. You need to control the password selection. We need to make sure the user is going to use a good password. We try to encourage this user, as you're going to see today in this class, please stay away from the popular password. For example, don't use weak password. Don't use the password, for example, if I said the password, all of them are going to be, let's say, 8 character. Don't use the same character. Don't use, numbers, only 1, 1, 1, 2, 3, 3. Don't use a password that contains your first name or middle name or last name or date of birth, and etc. This kind of information that can be expected. The other thing, since they have, I'm going to try to possible or popular password against, let's say, a wide range of the user ID. For example, assume that we have 10 students. So in this case, the system is going to notice that this IP address try to access different accounts. We need to lock the computer from making multiple attempts. This computer, first of all, you can specify this IP. Since this use the same computer, try to log in different account, lock this one, or if you try to have different computers, try to attack or access a different account, they have a multiple tries, so I'm going to lock them. So I'm not going to allow you to, in order to have, let's say, too many failed attempts. At the same time, if you have a specific computer or set computer, try to have a range account, or if you notice one computer, try to access different accounts and failed, in this case, block this IP address. The other kind of attack here, still see that we have a username and password and try to figure out a way in order to have access to unauthorized account. I mean, unauthorized access to the account, okay, that we are not authorized to access. The other thing is called the password guessing against single user. It's similar to like a specific account attack, but in this case, I'm not gonna just try to submit the password guess without knowledge. Here I'm gonna say, I'm gonna collect all the information about you. For example, do you have a user, Alice? Go to the social media for this, or account with the Alice. Gather many information. For example, first name, middle name, last name, address, pet, if you have a best friend, boyfriend, girlfriend, etc. And collect information about that. Then after that, I'm going to use this knowledge that I have about this account holder then in order to guess the password. So let's see here, might be the password going to be his or her birthday. Let's type her birthday. Or she born, for example, a specific city, let's type the city as a password. And etc. You see that this kind of information is going to help me in order to have more educated guess about the user password. So in this case, as a countermeasure, we need to control the password selection. Again, that's why when you try to type your password, there is some system going to say this password weak. You cannot use, for example, the previous password. When you, for example, change your password, the size of password must be at least, for example, 20 characters. For example, you are not allowed to use only character, let's say, alphabet numerical value. You have to use special characters, and etc. Make it complicated. Okay, and also you need to train the user in order to use the password selection, which we don't have this kind of training here. Okay, right now, anyone when you start, I'm not talking about you guys. I'm talking about the people that maybe they didn't use computer. Okay, until late. Their age. So they still, oh, actually there's some uneducated people, when they ask them to choose the password, they try to choose the ones easy for them, okay? And maybe they're going to use the same password, different accounts. We're going to see this one was kind of attack. And at the same time, they may share their password. They said, okay, I'm not going to hide anything. I don't have anything to hide, so it's okay. I'm going to use easy password. So we need to educate the people, okay? The user in order to wisely use good password. The other kind of attack here is a computer workstation hijacking. So in this case, I'm going to try to wait until you lift your computer, okay, on. You leave the workstation. Then after that, I can set in and starting, for example, sending email from your account or try to guess your password or any encryption key stored there. It happens many times. I saw this one when it came with the IT. My office used to be downstairs in the labs. Okay, there is a room inside, I think, not the room one, it's 1112, yeah? We had many labs downstairs in the IT, in the computer science. My office used to be inside these labs, okay? When I leave at night, and the reason behind this one, because I'm driving back home, so I'm trying to avoid the traffic. Okay, anyway, when I noticed that many students, they left their computers on in the station downstairs. And some of them, their email is open. So the only thing that you need just to submit, or maybe send the request, change the password to the IT department, or maybe said I cannot log into my account, or maybe send an email to someone else using that guy email. Okay, anyway, so the countermeasures here can perform the auto logout. With the reason behind this one, because you try to avoid this kind of attack. Maybe give you 1-2 minutes if your computer, you didn't touch anything, keyboard in your computer, didn't move the mouse, then the system automatically going to be logged out. The other kind of attack, exploiting the user mistakes, which is going to be if the system, generally speaking, assigns a password to the user more likely is going to write it down, okay? Because it's like, what? It's difficult to remember. Some systems, it's going to assign the password, especially when we try to work with the server remotely. They're going to assign you the password, the long, difficult, hard to remember password. So the system or the user are going to say, okay, I'm going to have a piece of paper, I'm going to write the password, which X, Z, Y, Z, whatever weird characters, it's hard to remember. This situation is going to create the potential for the bad guy in order to read the written password. Okay? The same thing you can see in the movie. Actually, there's still people write this one. Just check below on the keyboard, or if you have a picture. Behind the picture, you're going to see this guy write his password. Okay? I saw some people, they wrote the password with a sticky note in the monitor. They said password, and they typed their password there. A user may intentionally say share the password, and the reason behind this one to allow, for example, enable his people, a colleague, to share files. For example, this is, well, maybe you're gonna leave and say, okay, I cannot log in and use the printer. Can you give me the account password? I need to use your account to print some piece of paper. Yes, go ahead. This is my password. Attacker maybe is gonna trick the user account manager into revealing a password, which happened. And by the way, we have, phrase using security. The easy way to get the password is ask for it. This is the simple, easy way. You can call and you can smoothing, you say the phone number, it looks like the phone number came from the IT department or your boss, and say, hey, I tried to log into your account, or you need to, someone tried to log into your account, we need to provide your identity. Could you please type your password or tell me your password to log into the system? Oh, we're making some updates and we need to make sure that we're gonna set the password. Give me your old password or the account password in order to allow you to reset your password. Or maybe I'm your boss, I'm try to log in your computer, give me the password. It's gonna be easy. Or maybe you're gonna call and say, pretend to be your Alice, and hey, I'm Alice, I tried to log into my account, I logged out of my account. Could you please give me the password or set the password to my account? You're gonna be amazed how this is gonna be work. It works actually in many cases, most of the case. In order to, but there's some computers gonna be pre-configured with the password, and many people they didn't change these pre-configured passwords. Okay, so the countermeasure in this case, user training, password plus other authentication. That's gonna have multi-factors here. I wish if we have a multi-factor that allows us in order to log into my IT portal here. In my old university, when you used to student, that we have multi-factor. When you try to log into your account, your email, you have to have either gonna send you the link or the verification code to your phone number, or using a software can be installed in your phone number and gonna say there's someone trying to log into your account from this IP address. Are you authorized this one or not? You said just click yes or no. If you said no, it's going to be locked out. If yes, it's going to be allow you to continue access the system. Hopefully, they're going to implement this one in the IT. Exploiting multiple passwords used. But what's the question to you guys? You have many social media accounts, right? Do you use the same password or different password of each of them? So you have Facebook, you have Twitter, LinkedIn, and you have Instagram, and etc. Do you use the same ID in the password or not? Of course, you try to. Some are the same. You see, I'm not going to talk. Judge you, but that's the easy way, because some people are going to say, okay, it's better to use different passwords for different accounts. But the problem right now, if you have 5, 6, 7, 8, 10 accounts, too hard for me to remember every single password that's associated with these accounts. Oh, too much. And someone is going to say, okay, these are only social media websites, so I don't care. We can use the same password. But maybe you can use the same password for your bank account. Maybe you can use the same password to use the portal, IT portal, etc. So this is the problem that you're looking for. Why this? Multiple passwords is a bad idea here. Because, for example, you can use your password to say System 1 and System 2 and System 3. System 3 is well guarded. They have a firewall, intrusion detection, and etc. Antivirus, and you require from you to use a name and password to get in the system, and etc. But System 1 is weak. Okay, so anyone can get the username and password stored in the system, or the file stored in the system. So what the attacker is going to do here? Of course, the attacker is not going to attack the System 3, let's say the strongest system. I'm going to go try to attack the weak link with the weak system. Okay, for example, I'm not going to say, let's say Yahoo. They're going to hate me. Yahoo account, yeah, this is easy to attack. Every time I hear attacks, I gave up. When I hear something related to the Yahoo, I'm going to say, okay, I don't need to waste my time to eat. I know something wrong with these guys. Okay? So it's easy to attack the Yahoo. I will get the information, leaked information about the Yahoo account, so you can use the name and password, and the people get username, the ID, for example, Alice, and the password, for example, 1, 2, 3, 4, or somehow the hash value password. So if you manage to get this password, Now we're gonna try here the system with the strong system. I'm gonna use the ID for the same user Alice, and the password I'm gonna use the same password that I got from the Yahoo account, and see whether it works or not. If it works, that means I can defeat that system. Okay? So we need to control selection password on multiple account devices in general. Another thing, that electronic monitoring. That's what the people doing, the bad guys here. For example, you're sitting in the McDonald's or whatever, any fast food or any restaurant, okay, or mall. Then you said, okay, oh, there's free internet. I'm gonna log into the free internet. Then after that, you're gonna send username and password, log into your bank account, or checking your email, etc. Someone intercepts the communication in the middle because the system, for example, the Wi-Fi is not secure, it's not encrypted. They don't encrypt the data. So, or maybe someone sitting next to you is gonna have like fake open Wi-Fi. Okay, and it might be similar to the name of the whatever mall or the restaurant that you're sitting here. Okay, and you can do what? You can collect the information. Anyone can collect the information. Okay, or maybe you're gonna have a fake website link using this Wi-Fi. We'll try to log into a bank account. We're gonna provide username and password. They can capture this password. Okay, I hear the story about the girl. I think he was 12 years old. She was waiting for her order. I think she was with her family. I think she was in McDonald's or etc. While she waiting for her order, I think she just spent maybe 7 or 8 minutes watching YouTube video, and she managed to hack to another people's account at the same time. Because it's easy to how to hack account using the say unsecure Wi-Fi. She just followed the steps. I will try to find this video. If I find this one, I'm gonna share it with you. It's interesting. Okay, you see that unsecure Wi-Fi, and just a girl, young girl, just waiting for her order, and she managed to hack. I mean, many accounts and many people that's sitting at the same time waiting for their order too, by just watching the video. So you can imagine what the experienced hacker can do in this case. So in this case, don't use any unencrypted communications. That's in the passwords or exchange the passwords here. Which I mean the main thing that many people said they saw them. I talked to many people. They said, "I like it. It's a free password, and I don't care. I don't hide any information." But remember, the people that anyone can intercept the communication. And while you're sitting waiting for your order, maybe you're gonna somehow check your whatever, bank account, so you're gonna lose the information that you have. Anyway, so it looks like we can summarize this attack to the password. Attacks could be the target of the particular account. Can target any account in the system. Okay? Attempt to say common attacks path, maybe it's gonna be someone from outside the system, or someone might be from the outside. So someone's gonna try intercept the communication that you use here. And may only require one weak password in order to defeat the system. The same thing if you have someone try to exploit multiple password use. So in this case, only required to have the one weak password, or maybe one weak system is not well protected. They can use the password there in order to access the other system. And generally speaking, we can generalize the countermeasures as following. It might be user training, user training, user training. This is the first one. We need to have, of course, they didn't talk about the intrusion detection and the firewall, the system, and also similar password combined might be with another authentication mechanism, which the one that use 2 factors here. Okay? So let's take a look. What if some countermeasure we're going to perform here? One of them that we're going to lock the account if you try to have like multiple failed attempts. Okay? Password retry. So in this case, in the username either gonna be, generally speaking, gonna be public. It's easy to guess the username ID, and all our username ID is available. Okay, this is public information, and the bad guy can perform what's called brute force attack. Yeah, because what they need to do here in order to access this is ID and this is the password. Okay, assume the password in the IT they have like specific security policy. As I mentioned, I'm just giving a simple example: 8 characters. Okay, so it means you have to 8 characters from A to Z, only lowercase, for example. So for the bad guy, it's gonna be all of them is gonna be 8, up to all of them is gonna be Z, all the combination of the password. Of course, there's A, B, and A, B, C, and so until you figure out Z. Okay, so try to perform the brute force attack, create every single password, and type them. In order to prevent you perform this kind of attack, most of the system, or all the system, actually they have what's called account lookup mechanism. We're going to look at the account. And here the problem with that, we need to figure out how many times I'm going to look at the account. After, let's say, how many tries, for how long. Okay, some system give you 3 times, if you 2 tries, and how long? There'll be 10 minutes. Some of them you have to call, locked for account permanently, until you call the front desk or the help desk in order to help you in order to regain your access to your account. Okay, so what extent do I should be? It depends. You need to figure out a way or something in balance between the security and convenience. For me, security, I'm looking for an account until you call. Okay, after 1 try. This is extreme case, but this is going to be inconvenient in this case, okay? But because when you type your password, maybe your finger slipped in your keyboard, or maybe your keyboard at the time let you down. So in this case, you try to type the password, you're not going to manage to do that, okay? You may fail. So give me 2, 3 times, it's okay, acceptable. How long? 10 minutes, it depends on what kind of account. For the bank account, I believe it's going to be until you have to call. Okay, because someone tried to log in 3 times, try to access your account. Now you need to call in order to report. I mean, I know it's inconvenient, but in order to secure accounts, it's going to be a good idea. For account for social media, etc., you see that 10 minutes, 20 minutes, it depends. Okay. Another mechanism that you're going to perform here. What if someone gonna forget his or her password? Okay. So when you forget the password, you have many techniques, many mechanisms out there. The first one. They can use emailer set, one mechanism, send you a link to the email in order to reset your password. Okay, for example, you try to log in your bank account, then you're gonna send the set. We're gonna send you a reset email to your registered account at that email or that at the bank in order to allow you in order to reset your password. Okay, but there is some risk if you only rely on the emailer set. That's what happened for the Matt Holland story. Okay. So most of them are going to say, okay, I'm going to send you a link to the email, although many websites are still only based on this technique only. Okay, for the banks, maybe requires something else. Maybe you require from you to answer some personal questions or security questions. We call this one personal knowledge questions. Okay, okay, which another fact or type of the something that you know. Okay. So you have to, before I send you the email or set, you have to answer some security questions. Okay, some of them make it complicated. Add another level or layer of the protection. Then I'm gonna send you, for example, you have to say answer the personal questions, security questions. Then after that, you have to provide me with the code. I'm gonna send you a phone. Once you perform this information, I'm gonna send you email or set. So it looks like we have multi-factor. Of course, for some people, if you give him multi-factor or forget this password, they're going to have this inconvenient. So that's why maybe it's not for every single account. For the bank, etc., maybe you have like some, let's say, multi-factor in order to reset your password. The same thing, you have multi-factor and log into an account, and you have to specify go over multi-factor authentication in order to reset your password. Okay. Let's go over the security questions. It might be easier way. Okay, for an attacker to obtain, let's say, access to that account, then guessing the password. Why? Because many of these security, personal questions, security questions, based on what? On the public information available online. And we're gonna give you like, by the way, if you're interested to learn more about this one, take a look at this link. We have a paper that's gonna talk about the personal information leaks during the password recovery of the internet service. Okay, this is an interesting paper to read. So let's take a look at what happened to Sarah Palin, who used to be the vice president candidate, and also the governor of Alaska, if you remember. So on September 16, 2008, her account, her Yahoo account, again Yahoo, okay, was hacked. And how? They have the guy at that time, by the way, his name is David Colonel, okay? And David, I guess, used to be a student at Tennessee University, I guess. He was 22, 23 years old. I'm not sure. I guess 22. This is the right thing, I guess. Okay. Yeah, he used to be a student at the University of Tennessee. What he did, he managed in order to reset her password or account. He figured out what? The answer to the security questions. the zip code. In order to reset the password, you have to answer the following question. First, the zip code. In the Alaska, Wasilla, we do have only zip codes. They try both of them. Either this one or this one. This is easy question, and all the information available. Date of birth, thank you. Thanks to the Wikipedia, there's information available public. And also where did she met, for example, her spouse. It was everything information, and the Wikipedia met, taught in high school, blah, 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 all the information are there. So the only thing that you're going to use, how can you use this one in order to guess it? Okay? The guy or the Dave managed to know that to reset the password and also put the password in the specific website. I mean, everyone can get access to this website and try to access account and gain access to her account. Then after that, Yahoo detected the attack, then locked her account. Okay? Of course, this guy sentenced, I think, to 1 year with the federal prison, I guess. This guy, I'm not sure about this, how long they put him there. But this is the problem here, okay? So this is security questions. And security questions, if you're going to be honest, so anyone can get this information because we tend to share every single, activity in our life with everyone, which I don't know why, okay? So, the problem with the security questions, the problem here, if you're going to be honest, okay, it might be this answer can be easy to find out because you're going to find all the information available in the many websites, okay, public. If you try to make it hard to answer, now you're starting to lie, okay? When you start to lie, okay, you're going to forget the answer to this question. For example, what the zip code, you're going to say, whatever zip code you come up with. For example, where you met your spouse, you're going to use weird names or which city or weird answer. Yes, it's complicated. Then after that, you're going to forget this one, so you have to do this one again. So now we're going to take a look to how the password is going to be stored. How can you store the password? This is the main thing here. Then what's considered a good password? Okay. I'm not going to see how can to submit the password, but although I'm going to show you how can you use remote user authentication, which is kind of going to show us some protocols allow us to submit the password in a more efficient, or say, secure way. Okay? So the storing password, the easy way in order to store the password for us to work. This is ID. I'm going to create a file called this one password, the text, for example, and this file is going to contain what? The ID and the password. Alice. The password 1, 2, 3, 4. Pop, for example, 5, 6, 7, 8. And this is the easy way. This is a bad idea. Okay? Because the attacker is going to manage to access the system. If your system is going to be compromised, so the attacker can manage to access this password file and can figure out every single password associated with every single user. Okay? So that's bad. Someone is going to say, okay, how about the other option? You're going to use the password, the ID, and I'm going to encrypt the password. Oh, that's great. You can encrypt the password. But the problem here, where we're going to store the key. The third option with a better solution, we're going to use the hash function. So in this case, somehow I'm going to use the ID, and I'm going to hash the password. Of course, I'm not going to hash the password like this, but somehow I'm going to hash the password with something else in order to, if anyone get access to the system gets compromised. You can say this is Alice, and the password, for example, 160 bits. And Bob is going to be another 160 bits. Okay, it's not going to be in the plain text. For the attacker must do some effort in order to figure out what's the password going to store there. We're going to see how can you perform that. So let's go back to more details. We'll store the password declared or the plain text. We do have a different types of attack. The first one, the easy one, you're going to do what? Insider attack. If the password is going to be stored in the system, the simple thing, for me, if I manage to get the password of the users, I don't know why, but it's going to be tempting to get this kind of information, yeah? If you give me a choice, do I want to see all the passwords associated with every single one at the IT or not? 99%, including me, I'm going to say, yes, I want to see them for curiosity, okay? So the insider attack, someone, normal user, read the password, or the database that contains the password, and learns the other user password. As a countermeasure, you're going to do what? You're going to ask control the password for the database. So that means not every single one, which is the one you're doing in the IT, not every single user have access to the password file. Okay? There's another insider attack. okay, we don't trust the normal user, the admin, okay? With the IT department, for example. It might be the password that learns other users, okay? How can you protect in this case if you use this one in the plain text? We can't. Because the admin is going to be, what? Must be trusted. If you don't trust the admin, well, going to have, and you are going to store the username and password, okay, in the plain text, the admin definitely is going to get access to this kind of information. If we don't trust them, in this case, then we do have a problem. And we cannot protect against this kind of attack, okay? Because password and plain text. The outside attack, maybe someone from the outside gain unauthorized access to the database. In other words, the system gets compromised, and someone from the outside managed to get the password file that, or the database file, the password file that contains the username and the password in plain text. So in this case, don't store the password in the clear. That's the meaning of the plain text. Even in order to avoid the outside attack, and also in order to avoid the inside attack. Even, actually I don't trust the IT department in general, because you trust with someone with username and password? No way. Okay? I don't know them, but I don't trust them. So the other option, the second option, how about to encrypt this one? The same thing here. We need to store the username and password. The password is going to be encrypted format. Okay. The good thing, someone is going to say the password is going to be encrypted. But the problem here, we have two things. We are going to store the key somewhere in the system. Why? Because now when the password is going to be encrypted, when someone tries to log into the system, going to provide username and password, we are going to encrypt this password that we got from the user. I'm going to use the password prime. Then after that, try to find the match. This is the ID of the user here, and see whether the match, the encrypted has the computed password that provided by the user, whether it's going to be matched the stored password in the system or not. If they're matched, then going to say, okay, the user is going to be, the access is going to be granted. Otherwise, it's going to be denied. All right? The problem here, I need to compute the password every time the user provides the credential. Where are we going to store the key? Somewhere in the system. Okay. The same problem. If you don't trust the admin, so the administrator is going to do what? Going to get access to this file. And they're going to get access to the key. At the same time, for the outside attack, if the system got compromised, someone is going to perform the same thing. You're going to get access to the password file, and also going to find the key somewhere. So it's going to get access to the system. So this is bad idea too. So what we're going to perform. And also, the encryption and decryption can be expensive. We need to find something else. How about if you store the password, instead of storing the password in the plain text form, encrypted form, maybe you're going to do what? Put this password somehow through a one-way hash function before going to be being stored in this case. So we're going to have the ID and the hash of the password. Oh, that's a good idea. Yeah, so far so good. Something interesting. Even if someone gets access to the system here, the only thing they're going to see, for example, Alice and the hash value of the Alice, Bob and the hash value of the Bob. Okay, with, for example, 160 bits or whatever the hash function we're going to use. We're going to talk about what kind of hash function we're going to use in order to achieve this goal. All right, now let's assume we're going to use MD5 or SHA-1 or SHA-2 or SHA-3 in order to compute the hash function. Let's remind you what the password, let's say the hash function properties. I'm talking about the secure hash function, okay? Variable size input, produce the fixed length. Great, good. Small output, great. There is no collision, or it's hard to find the collision. Remind you with the collision to say password is going to be hashed to the same hash function. Make it hard to find, okay? Or maybe someone's going to have the, you say, you're going to have, for example, the hash value of the password, and it's hard to, yeah, you do have the password, it's one-way function. It's hard to find out the password, or let's say the PLH that you use in order to compute this password. Okay, this is hard to perform. It's easy to compute the hash value of the password. It's hard to reverse operation. So in this case, again, if the tracker or the admin tool get this information, access the database file, I'm going to say practically impossible to take the hash value and directly determine the original password by just looking at the hash value, because based on this property. Okay, we are going to change a little bit, okay? We're going to see how can you perform this case. So when someone tries to log in the system, going to have the ID and this is the password. The system going to perform the same hash value for the password, then try to grab or fetch this information from the password file. Check whether ID Alice and compare the computed hash value for the password with the stored hash value of the password. If they are matched, then in this case, we can say the system actually granted, otherwise it's going to be rejected. So far, so good, right? What the bad guy can do here, we're going to perform what's called the brute force attack on the hash password. That's one way in order to attack this one. Okay? So given one or more target hash value, we need to find the original password. So if I manage to have the file, I need to have what? I do have many hash values, and I need to manage to find a way in order to figure out the corresponding hash value, or the corresponding value of the password, or the original password used in order to compute this hash value. Okay? So the simple thing for the attack, I'm going to do what? I need to start with the largest possible password. Of course, I need to get some information about the system, the security policy of the system. When you say security policy, set of rules that you need to achieve here. For example, it's one security policy going to associate with the password. The password length must be in bits, for example, or in character that contains whatever kind of information, okay? Mixed alphanumeric data, and a special character, etc. You come up with this way, you can come up with, you can produce all the possible password, right? You can do that, okay? For example, the size of n, I need to produce all the possible passwords in n character. Good. And for each of them, for example, I need to compute the hash value and see whether I find a match or not. If I find a match, then I'm going to say for the Alice, for example, the hash value, the stored hash value, if match any of the computed hash value, so I can't tell what's the password, right? That's what we're then going to do. And that's what's called in this case the brute force attack. You try to, every single possible password value, hash this one, then after that you try to check whether you find any match or not. Okay? And this kind of attack depends on the size of the possible hash or the password set. If the size is small, it's easy to figure out and find out this one. Right? That's what's called, the brute force attack. Another thing the attacker can do in this case, I do have the ID and I do have the hash value of the password. So in this case, the simple thing I can perform that what it's called is better than, or to speed up the brute force attack. Instead, in order to do this one, come up with every single possible password, then you compute the hash value by yourself. Thanks God. We do have the pre-calculated, let's say, tables for all the possible hash value. For example, as you said, the size of the hash value, for example, in character, and the character in the hash specific, let's say, format. For example, only alphanumeric value from A to Z, uppercase, lowercase, and 0 to 9 digits. Okay, and the size of n, we do have like pre-computed hash value based on specific hash function used here is there. The file is called the ID, and the pre-computed hash, it's gonna be the password, and the pre-computed hash value of the password for every single combination. It's already pre-computed for you. Save our time. Okay, that's what's called the rainbow table. And the reason behind the rainbow table, the name here, it's have a different ways in order, different characters or different, mechanism, technique in order to store this information in a more efficient way. Okay, if you take a look to the size of the file, it can be maybe hundreds or thousands of terabytes, because you're gonna find all the possible combinations of the passwords, and you need to compute using this one different hash value, or the hash value of every single possible combination of the password. Okay, it's gonna be too large, but using the rainbow technique, they call this one rainbow tables. In this case, you're gonna have like special structure. They use a mechanism in order to have different mechanisms, different structure in order to reduce the size of the file, from for example, 1,000 terabytes into, for example, 1 terabyte or maybe less, like compression techniques. Okay, so in this case, for the attacker, the only thing you need to do have access to somehow the database file that contains the ID and the password, hash value of the password. Then you're gonna just perform a lookup with it. You know that the size in character, for example, 10 characters. So I will fetch the rainbow table that contains 10 characters using specific hash function. Then the only thing you do, compare. If you find match for the hash value in the database file with the hash value that be computed in the rainbow table, then in this case, this is the password that I'm looking for. Okay? In order to countermeasure this kind of attack, we need to follow the following steps. The first one, longer password is not shorter password. For example, you see that even the time, the character, for example, 5 characters, 8 characters, easy to crack this one. Easy to compare or compute, for example, the rainbow table that contains all the possible hash value for this size of the password. Make it longer. That's why now longer password, this is a trend here. Okay? The other thing here, we need to make it complicated in order to compute the hash function. Right now, when you talk about the hash function, we talk about MD5, SHA-1, SHA-2, SHA-3, and etc. Yeah, they are fast. Actually, we are not gonna use them in order to store the hash value or then store the password or in order to compute the hash value of the password. Why? I don't want to use fast hash value of hash algorithm in order to compute the hash value of the password. And you need to make it complicated for anyone try to attack the system, by using slower hash algorithm. So again, we know that we talk about the hash algorithms. We said we do have many hashing algorithms. Okay, the one is gonna be like MD5, SHA family in general, but there are several reasons not to use them. They are fast, or generally speaking, extremely fast, and we don't use them here. I need to make it complicated for the bad guy to recompute the hash value. So make it longer. For example, instead use, for example, 1 second, for example, you're going to spend, for example, 1 minute in order to recompute the hash value. Of course, not 1 minute, but it's going to be complicated. Okay? Make it longer in order to compute that. For example, for the MD5 and SHA in general, we can perform, brute force attack, yeah? You can guess, especially if you have like a lot of compute resource, CPU, GPU, and etc. Okay? So it's allow you in order to what? Use this, let's say, compute resource or computer resource, okay? Like GPU, which allow you in order to make, let's say, a lot of password guesses in the short period of time using the MD5 and SHA. I don't want to do that. Okay? We are going to use the password, another technique used with salting. That means I'm going to add extra piece of information and hash with the hash value. Okay? Which, generally speaking, these techniques, the MD5 and SHA-1, they don't, natively use a salt. Okay? In order to, it's going to be hashed with the hash value. So what do you mean with the salt? Let's take a look at this one here first. So in this case, I'm going to take the ID, the user. I'm going to introduce this, say, a value generated by cryptographically secure function that's going to be added to the input of the hash function in order to create a new unique hash values, let's say, or hashes value for every single input. Okay? So salt is like timber, or let's say a unique ID or value or whatever, generally speaking, can be 30 bits, 32 bits, or 64 bits, or maybe longer, and can be generated a random number and can be stored in the table. So in this case, the database table is going to be what? We have Alice. I'm going to use salt, for example, SBit. Random can be stored here in the plain text. And now I need to compute the hash value of the password with the salt. Okay, so if we say we have Alice, assume the salt is going to use S1, whatever the value, and the password, for example, assume this is the password, just write the password 123. I'm going to, in order to store this information, I'm going to hash the password with the salt. So in this case, hashing in this case, you see what's going to happen, 123 with S1, this produce, for example, XYZ, just for example, okay? It depends on the hash value going to be produced. Assume that I have to have Bob. Bob is going to have, for example, the same password, but I'm going to use different salt. So here I'm going to compute hash the value. It's going to be 123 with the salt 2, and it's going to produce, it's not going to produce XYZ. It's going to be ABC. So see the benefit of using the salt here. First, when you compute the hash value, if you're going to use a rainbow table, you didn't know what the salt value you're going to use, right? So that means we're going to build the rainbow table for every single possible password combination, plus for every single possible salt value. Make it complicated, this one. So you are not going to use the pre-computed salt, or let's say rainbow table. Clear? Plus, if we have users, they use the same password, which is the case that we have here. those users use the same passwords. Using different salt here, when you compute the hash value here, we're gonna make it here by taking a log that the hash value here, you cannot tell whether the user is gonna use the same password or not. Even if they use the same password, the hash value is gonna be different here. So make the password unique. So again, this one makes the space required for the rainbow table to be like increased by 2 to the power s. Why? Because the size of the s is the number of bits that we have in order to the number of bits for the salt value. Make it complicated. Okay, also the pre-calculated value, as you mentioned, from the rainbow table is going to be no longer feasible here. Clear? So here, the salt is going to add it to the hashing process in order to force their uniqueness, increase their complexity, okay, without increasing the user requirement. For the user, the only thing that you need to provide what? I'm not going to add anything to you. The user got this is my ID, this is my password. When you register for the system, provide username and password, the system going to contain, for example, the ID is Alice. I'm going to choose salt value, for example, S1, whatever the size here. Then I'm going to compute the hash value of the salt with the password. This information can be stored here. When you try to log into the system, the user going to provide username and password. The user or the system going to take the password here, the ID, go to the table, fetch out the value of S1, compute the hash value of S, for example, the password provided by the user and the salt value, and compare it with the stored hash value of the password with the salt. If they are matched, the user can be asked, otherwise not. So see, I didn't say add any increased user requirements. The only thing for user, the same process, but the way I'm going to store the data is going to be more secure. There's another way to not use buffer, make it complicated here. The buffer value for the salt, the value can be stored in the file. For the buffer value, it's going to be the value is going to be stored in the system. Okay, it's not going to be stored here. So, for example, when you use the Facebook, for example, to log into your system, the system is going to say, okay, the Facebook application here, I'm going to use the salt, the buffer value. By the way, if you're wondering why use a salt, I'm going to use a pepper, something you have the same ingredient, but you're going to add more extra ingredient in order to make sure the food is eatable. Okay, that's the meaning here. So pepper, salt, I know, weird names, terminology, but the meaning here is just to make the hash process, to force the uniqueness and also increase the complexity without increasing the user requirements. Okay? And also, in order to mitigate the most robotic thing, I forgot to mention this one, the password attacks like hash tables, or the pre-computed hash import tables in this case. So here we can add the pepper of the system going to be stored in this system specific value. You're aware of this one. So in this case, you're going to hash, for example, assume this one is going to be the password, maybe you're going to use a salt, and you have the specific unique value to say pepper stored in the system. So every time you're going to have the password, you have the salt, it's going to be stored there, and the system, when you compute the hash value, you're going to add this piece of information. So it's not going to be known even to anyone compromise the system. It's not going to be stored in the database. Okay? So again, just to summarize, why is the salt? The first one, duplicate password can be prevented from being visible to the password file. Remember, S1 is 2, different salt value, same value for the password, same hash function, produce the different results. So this anyone check, because for the attacker, try to find what? Okay, if you find multiple users have the same hash value, I'm gonna say these users are gonna use the same hash password. If you manage to figure out one password, one user, so I'm gonna say, okay, I'm gonna say use the same password for the rest of the users. So that's why I chose the salt, make it complicated, make it not visible, and enforce uniqueness for the data or the password value. Increase the difficulty of offline dictionary attack. Remember, for tables, the pre-computed table that contains all the possible password with the old combination password and also the old password, they say their hash function or hash value. Adding the salt, that now we need to include different value of the salt in order to come up with a rainbow table, make it larger. Okay. Make it, for example, generally impossible to tell if the person used the same password on multiple systems. For example, system 1, and you have a system 2. User, for example, Alice, use the same password 1, 2, 3. If you use different salt, this one is 2, for example, different salt, so the hash value is going to be different here. So even if you have access to these files, the same user ID, but you're gonna say, oh, different hash function. So a value, so it's hard to tell whether they're gonna use the same hash function value or not. Yeah, of course, try. If you figure out the value of the password of this system, one, of course, the first thing you're gonna perform, try to use the password, the same password of the other system. But by just looking to the password files, you cannot tell whether they use the same password or not. Okay, this is just a symbol of the Unix password scheme, the easy way. The symbol structure. We have a salt value. It used to be 12 bits, now no more. Okay. Then after that we have the password. This is the username and password. Username, for example, and the password here. We're gonna add the value to the salt. We're gonna use slow hash function. I'm gonna talk about this function in more details in the next slide. I'm not gonna use the normal hash function that we know. I'm gonna use one slow, because I need to make it harder for the guy. For the bad guy to spend a long time in order to guess every single possible password. If you use the fast password that you know, MD5, SHA-1, and SHA-2, SHA-3, so the attacker is going to do this one more efficient. It's going to be, it can come up, or can compute the different password in a more efficient way. Okay, so we do have here in this case, once you get this information, you're going to have the user ID, the salt, and this is going to be the hash code with the hash value of what? Of the salt with the password. When the user log into the system, here the register, when the user log into the system, just provide user ID here. Based on the user, of course, you got to provide me the password here. So using the user ID, just in order to perform lookup in the password table, in order to retrieve the corresponding value of the salt, use an order associated with the password, use the same hash function, the slow hash function they use when you register the user, or enroll the user enrolled in the system, compute the hash value, compare with the store the hash value. If they match, allow access to the system, otherwise you're going to be rejected. So this is, the best practice with the hash value of the password can be stored, ID, salt, and the hash value password of salt, and maybe you can make it complicated at purple. Okay, so what kind of hash function I'm going to use here? This I want to add here. We're going to use what is called password hash functions. Slow, adaptive speed. What does that mean in this case? This kind of hash functions, we call this one the password hash function, is different than the hash function that we know. It's not MD5 and SHA. It's bcrypt, one of them, scrypt, and argon. Okay? All of them, they have a different rate in order to perform that one. I think this one's still new. This one, scrypt is much slower than the bcrypt. And here, the interesting thing here, you can specify, for example, the work factor, for example, make it complicated. You can add, for example, one parameter in order to make this one and be like, let's say, make it slower. For example, I need to perform, for example, 5 iterations more, or 6 iterations more, or 16 iterations more. That's what's called the work factor in this case. Okay. So in this case, when you perform this hash function, assume that give you an example. So bcrypt, you're gonna say this is the function, the hash function, and here you need to provide me, for example, what the password that we need. Okay. What the salt value, and here you have to give me like a parameter. N, okay? What's going to be for how many iterations you're going to perform here? The larger this number, the slower the encryption. So you can make it slower and slower by adding more factors here, okay? So one of them is going to be consume. I think the bcrypt is going to consume more. It's going to be CPU hardener. What does that mean here? That's me computing the hash function, in this case, requires many CPU cycles. So you can the number of iteration using work factor, which makes exponentially, I guess, harder to brute force attack. That's one thing here. Since the computer gets faster and faster, computer source becomes less expensive. Okay. So in this case, we can simply increase the bcrypt work. Okay. Factor to increase, resource consumption in this case. Add 2 more iteration, and at the same time, it's going to consume more resources by increase this one. You see that you have some factors. By the way, you are not going to implement this one by yourself. It's available. You can use bcrypt, you can use scrypt, you can use PBKDF2. I don't remember. What this letter means, but I guess it's one protocol and another argon 2 with another protocol here. Let's take a look at the scrypt. The script much slower than the bcrypt, okay? And this one is gonna be like the script is the CPU hardening function, but also gonna have an advantage of being memory hard. So this one is going to consume the CPU resource plus the memory resource. Remember, I will try to make sure the bad guy harder to compute the hash function. It's not fast. Spend long time, consume more resource, okay, to make it too slow. Okay, and this compared to the other type of hash function that we use for the cryptographic technique, to compute the digital signature. The other one must be fast. This one, I don't want something fast. I need to make it harder because the attacker try to perform brute force attack, try to build, say, a rainbow table. So if you use the slower or MD5 or SHA-1 or SHA-2, for them, it's going to be easy to compute all the possible hash value in less time. But I want to make it harder for them, consume more time. Okay? So the other one, I think, arrogant too, was going to be offer, I guess, more flexibility in this case. It's going to be add the third dimension here to the cost here. With here, it's going to require for you to control the number of threads it's going to be used in order to compute the hash value. Make it more complicated. Okay? So the takeaway from here, we're going to have the password. We're going to store the password not in plain text. We're going to hash the password. I'm not going to hash the value of the password like using normal, or say the fast cryptographic hash function. We're going to use the slower hash function. We call this one password hash function. Well, this is some examples for that. Slow, okay? And also we're going to hash the salt in order to make sure that it's hard to use the pre-computed hash table, okay? In order to guess the password. Just to summarize here, we have two different, attacks to the password. I'm going to perform the brute force attack or to use the dictionary attack. Okay, when you say the brute force attack in this case, going to be trying every possible combination of the password based on the password length. I can try to figure out, and then after that, figure out what you compute all the hash value. Okay, it depends, of course, on the password length and the key space, the length of the password in general, and also at the same time, it depends on the hash value that you use. That's why I'm going to use the slower hash function, and also it can have a factor that will make it more complicated to compute the hash value, or take a long time, or consume more resource. The other type of attack, I'm not going to try every single possible combination. I'm going to have it's going to be brute force attack, but in this case, I'm going to come up based on the large dictionary. So all the possible, we're going to use the list from the dictionary. So it's going to be stored the pre-computed value. It's going to be stored all the, possible password, most common password, pre-computed hash value. Then you can use in order to figure out what the hash value based on the matching for every single, compared with the hash value stored in the password file. Every single password that comes with the file must be the dictionary must be hashed using salt, each single value of the salt. Then after that, compared to the stored hash value in the database. We're going to talk about the password cracking in general. When you talk about the password cracking here, in this case, I'm going to use as a process of attempt to gain unauthorized access to the restricted system using common password or algorithms that guess or allow me to the password here. Of course, we talk about the rainbow table with another way of the dictionary attack. You're not going to compute this one by yourself. Someone else make this one for you. It's going to be available. You can use them in order to try to guess the password here. So we do have many softwares. We can use them in order, or techniques, in order to achieve this goal. Okay, in order to crack the password. We say the crack the password, you can guess the password, either using the common password or using an algorithm or the software. And the famous software I'm going to use is going to join the wrapper with one software, open source, allow you use in order to crack the password. And this one is going to do the combination of two things: the brute force attack and at the same time dictionary techniques. Okay, try all possible password, and also you have the pre-computed password. You can tell me, for example, which table you can use in order to help you or be computed. I'm not sure we can. Try to have, by the way, short tutorial to talk about the certificate, digital certificate, and maybe give you short tutorial how can you do the password cracking. I will try to this one either next lecture or maybe next week. Okay, somehow we'll see. Interesting to see how to use this one in order to crack the password. There's many other approaches, by the way, okay? Modern approaches in order to attack, in order to guess the password, in order to crack the password. Although they have a complex password policy concept, now right now doing better job in order to protect the password, in order to train the people to come up with the password. But at the same time, the password crack technique also has improved. And the simple thing, we can talk about this one. There are some sophisticated algorithms available which allow you in order to generate all the potential password. At the same time, we do have like examples of the actual password, and thanks to the leaks that happen many years, every year. We hear that they leak. We can say have like access to the real password of the user. So by studying them, you can understand the trend or how the people choose the password, and based on this information can help you in order to better guessing the password. Okay. So as I mentioned, we have many cracking tools. I'm not gonna cover all of them here. I think this link, if you click over this one, you try to find the updated one 2021 identified, but there's many websites that give you like the, let's say, popular password cracking tools. If you try to test any of them, I encourage you, advise you to use this one under the virtual machine. Don't download this link or whatever the software using your machine or the host machine. Do all the computation, all the tests using the virtual machine. You can create another instance, or maybe you can use the seeds instance that you already have there in order to try to test them. Okay. Another mechanism we can perform here in order to reduce that kind of attack against the password, I need to make sure that deny to anyone, the bad guys, to access to the password file itself. Okay. So we can block what's called offline guessing the password. Someone try to access the password file in the system by doing the following. Only available to the privileged user. Not every single one of the user can access the password file in the system. And sometimes some systems, as the Unix doing here, to do like the hash value or the hash passwords can be kept separate file from the user ID. So we're gonna call or use what's called the shadow password file. The shadow password file, that what, as you mentioned, Unix doing system, they're gonna separate, the user ID and the hash value of this file. To have two different separate files and to try to protect the shadow password file that contains the hash value of the password. Reduces the chance of someone compromising the system, may get the file that contains the IDs, but they're not gonna contain the file that have the shadow file. But actually, if you know where of the system, and we do this one, the ethical hacking course, we show this in different ways. How can you somehow manage to access the shadow file? They still have vulnerability, so controlling by the password file by access control is not enough, because there's sometimes many systems, include most Unix system in general, are susceptible to unanticipated breaks or break-ins. Hacker may be able to exploit software vulnerability in the operating system in order to bypass any access control, which is the one thing. If you have a system, for example, Windows, and this system is not updated or not patched, so someone can use this flaw or this exploit this vulnerability in the system in order to gain access or in order to bypass the access control, so they can get access to the file. Okay. Remember, we try to reduce the password attack to block the offline guessing. Try to prevent the bad guy in order to access the password file that contains the password or the ID and the hash value of the password. That's the goal here. Accident with the permission making is readable, that might be happening in this case. So compromising all the accounts in general. Users with the same password in other systems. Thank you. Use the system, and that system and other system is not well protected. So bad guy managed to get the password, then gonna use this one in order to access the system. Okay. So a lack of the weakness in the physical security, which may provide opportunities for the attacker in order to access file or the password file. Sometimes maybe you're gonna have a backup file which contains all the information of the password file, etc. You're gonna store this one somewhere in the office and you are not gonna put this one inside the protected place, so anyone can get this file or this archive backup file, and you can manage to get the password files. Okay. Or user maybe use a bootable USB. You can use one, plug this one in the computer, log into the system. So I'm not going to use a Windows, maybe a plug or use a portable USB that contains the operating system allow me to access the system. So in this case, I can manage to access whatever data stored in the hard disk. Or someone is going to observe the communication between the sender and receiver, or for example, try to remotely access the system. So you're going to sniff the password in the network traffic. So you can manage in order to get the password if the data is not encrypted in this case. Okay? So I will stop here. I give you, let's say back at 11 o'clock, okay? So we're gonna see how do people pick their password. And you're gonna be surprised. You see, actually they don't. So let me say back and okay, see you. Okay, we're back. So let's see how do people pick their passwords, okay? As I mentioned, often they don't. So just in simple examples, okay? In April 1994, English teenager, okay? The code name is DataStream, Cowboy, penetrated, Pentagon computers via the Air Force Rome, okay? This laboratory located at the New York, okay? And started probing, Korean, nuclear, facility, and so they started trying to gain information access. Actually, he has help with someone else. I think that guy is 22 or 23 years old, okay? Anyway, how they did that? The simple thing is the default, the guessing, what is called the default guest password to log into the system. So they managed to use this guessing guest password, and they're going to access the system and start collecting the information. I think there's either a system for a couple of days before they got, catch. Generally speaking, many surveys show that half of the user leave the default password in the place for their routers at home. I wish if we can do this test. My plan to do this class and the security class to do what? Maybe give the students a class project, for example, try to go over the Chicago area. I try to figure out how many passwords the router can be logged in, or what passwords, Wi-Fi passwords have like the default password. If you check this link, this one paper, give you more details about, they collect some information about the routers and you tell you, for example, how many, most of the users in Michigan are going to leave the default passwords in place. They don't change this one. Even some of them, my neighbor. Example that, for example, that's what the most important thing that we need to protect in the world with nuclear, missiles. Okay, this is a claim. Okay, I'm not sure is it correct or not. I found many different resources. Some of them they said that happened. Some of them they said never happened. And this information based on the source, the report from the former ICPM launch, officer Bruce Blair. They measured that in the 1962 up to the 1977, the passcode for the launching the missiles was what? All of them could be zeros. And the reason behind that at the time, they said, because we don't waste our time, won't try. At the time, the situation between the United States and Russia was, intense, okay? So they are afraid of each other. They said, maybe you need to have an easy way in order to launch it, or you don't waste our time just to remember what the passcode. They said never happened, but I think as you mentioned, many sources said that that was the situation at the time. Okay. Anyway, just to give you a few examples, the people they don't, but let's give you about some realistic example. Okay, of someone that we can't control. We have some data we can justify our thing. What we're saying here. This is just an example for the good and passwords. This is a bad password because it's easy to guess. It's not combined. It's only easy to generate, easy to compute the hash value, easy to figure out whether you're gonna, unguessed in general. Okay, it's not complicated. This is a good password. When you say good password, that means this one has combination. Although this one, the reason behind this one is good password because it's length compared to this password. This short one, this is the length. This have mixed, character alphanumeric data. This have maybe special characters, which I believe is much better than the rest here. So the question here, how would you define the password, a good password? Before to answer this one, let's take a look at some details, some information about how the people, or what the most common passwords in general. We do have what is called the splash data with the one organization, which is going to do this one for the last decades, okay, doing what? Revealed its annual list of the most commonly used password for the year, or of the year. Every year, I didn't find the new one for the 2020. I know the 21, but usually 2021 is going to reveal all the most common password in the 2020. Based on what? They collect the information based on the million of the records here. So what they're doing, I guess they're going to collect the information based on the over 5 million passwords that has been leaked online in each year. For example, the last year, for example, when you produce or come up with the reveal, let's say the 2020, for example, most commonly used password based on what revealed the 2019, okay, the last year. So too many records, on over 5 million records, which is going to give us clear hands how the people using the password. They did this one in the 2018. I do have the information 2018, which is going to be covered the password in 2019, and the 2019 will cover the password in 2020. I still didn't find the 2020, so I guess maybe it's going to be somewhere available. Maybe I'm lazy. If I find this one, I'm going to include this one in the link here. So let's do this one. This is the most popular password in 2018. Yeah? And based on 5 million records. The number one is 1, 2, 3, 4, 5, 6. This is the most common. By the way, if you find your password here in this list, don't worry, you are not alone. There's another 5 million people are the same situation as you. Of course, I'm sure that your password is not there. So that I mentioned here. Remember that we tried to guess the password. You didn't need to come up with a random generate every single possible password. The good thing I'm gonna use the most common password that year, and I can use them in order to try to guess the password of many users. Definitely, hopefully, it's gonna be worked somehow. Okay, and based on the information that we have, yeah, it's gonna be worked. When you notice that any change, this one compared to the previous year is any change. So still number one in 2017, 2018. And actually 2019, still 1, 2, 3, 4, 5, 6. Password as a password and a change, still number 2 here. What is it gonna be in the next year? It's gonna be changed the place. I guess it's gonna be number 4. We're gonna see the next slide. This one 1, 2, 3, 4, 5, 6, 7, 8, 9, up 3. That means it was the previous year was number 6. Now it's gonna be number 3. The third one, this one reduced down 1, and etc. You see that the password here. At that time, I think Donald Trump was, the president. So at that time, the Don as a password is going to be there. Okay. So this is the top 20, 25. That's 2018. This is the 20. The top of the most popular password in the 2019. You see that? There's still number 1, 1, 2, 3, 4, 5, 6. So the first guess for me to try to guess any password, I'm going to use this one. If not, go to the next one. If not, go to the third one, etc. Because this is the most common passwords. Sorry. And etc. I know why the dragon is new here. You see, admin, password, and etc. Welcome, weird. So we need to educate people actually in order to make sure that they must use or choose the password. These other characters, the common characters of the password that retrieved from the data, they note that the most use only alphanumeric character based on the 5 million records revealed with the password or leaked passwords. Most of them in the password dictionary, which is going to be the common password, known that password. Many users use the same password across systems because you have 5 million records, leaked records. So notice that we have the ID, they have the same password in many systems. For example, leaks from system 1, leaks system 2, system 3, they use the same ID and they found out based on the data that they have, all these ID use the same password. Okay, we still have some very common password, 1, 2, 3, 4, 5, 6 passwords, etc. People, when they force them to change the password, they must use a change a single character. I was like, actually, it's interesting to ask you. When you change your password, for example, for that My IAT, you didn't need to answer this question if you don't. Are you gonna change the entire password, or maybe change maybe single character at the end, or add more character to the password? In MIT, you know, you used to change the password every year. They change this one now to every 2 years. Yeah, I know why they did that. We're supposed to have short terms better than long term. So now if they ask you to change the password, whether you're gonna change the entire password or maybe add few characters to the password, in your case. Anyway, so most people, they do what? They change only one character. So in order to get the password right, it's difficult. We agree with this one. So we need to figure out to balance again between the security and the convenience. Yeah, for the security, you can use the password that it's hard to remember, complicated, but it can be inconvenient. If you try to enter the password, you're gonna spend maybe 1 minute trying to remember the password, then type all of them. Okay? Weak password, easy to remember, keep in your mind, and you say strong password can be difficult to remember. So what we can do here, choose long password with a special character next to them. Don't use, maybe it's better to use passphrase to remember the password. And the nice thing, if you have a complicated password, you can say, for example, it was a dark and stormy night, and this password will be the first letter. Okay? For every single word here. Maybe use different language. If you speak different language, you have mixed passwords that have different language. Meaning, allow you to memorize or come up with a passphrase. Don't use the dictionary password, the password that's known, or the personal information. Don't use, of course, don't use social security number. Don't use the birthday date. Don't use exactly your first name or last name. Some people use first name underscore last name. I don't know. Add something. Does it work? Don't use the same password in the system, because there's a problem. This one, maybe this information can be leaked somehow. So someone gonna, if you use the same password, so the system gonna do what? So the attacker gonna use the old password that found in the leaked system, also leaked data, in order to try to access your system. Okay? But we still, user compliance is extremely difficult. If you give you this instruction, maybe do this one time, 2 times, and after that say, oh, let's do this one, easy password. I don't have time to memorize all of them. Okay. We still have a problem with the password. We agree this one, okay? And the goal that we try to achieve here is to eliminate guessable password, because people don't listen, okay? So we try to figure out a way in order to eliminate the guessable password, while allowing the user at the same time to select the password that is memorable. It's easy to memorize, okay? We do have 4 techniques. We can use them. The first one, user education. We need to make sure that, or tell the users, okay, that the importance of using the hard to guess password. Try to educate the people, tell them here that please don't use the easy password, or the password that's easy to guess. Okay, come on the one, because the people, if you show them this, survey or this information, or they say the statistics that we have, the top or the most common password is 1, 2, 3, 4, 5, 6, and passwords, etc. So maybe the user, and tell them that, or explain to them the bad guy can easily use this information on the actual system. So please don't use, the easy password or guess password to use. Okay, please just use hard to guess password. And also, you can provide the user with the guidelines for selecting strong passwords, which the many systems try to do this one. We try to select the password to give you like, hint, this is a common password. The way that password you're going to use must contain this, must contain this, must contain this. If you try for example, ask you the password is going to be alphanumeric data, must be have an underscore, special characters. If you specify some, at least have uppercase or lowercase, mixed, and etc. And you see that sometimes they give you like check if you achieve this requirement. Yeah, if you have something missing, you have maybe an error, and it asks you, please insert the password or choose the password that contains the following, you say, guidelines, okay, on the policy. The other thing we can use the computer-generated password with the problem here. If you let the computer use the generated passwords, of course, it's going to come up with a complex one, but at the same time, user is going to have trouble to memorize them. The other types of the way that allow, remember, the goal here to eliminate guessable password while allowing the user to select a password that's easy to memorize. Okay? So we can do what is called reactive password in this case. So what do we mean reactive password? Now the system periodically runs its own password crackers to find guessable password, which is interesting here. Okay? So in this case, we do this one here. So in this case, I'm gonna allow the user, I'm gonna choose her password. At the same time, I'm gonna do what here? I have a list of the password that is gonna be weak, so I'm not gonna allow you to access them. Or you store your password, you select the password every month or every week, or let's say at the IIT we have every 2 years at the beginning of each 2 years, for example, you have to change your password. So allow users to change their password, then you're gonna perform, let's say, password cracker against our database in order to make sure that whether I find any guessable passwords or not. Because the bad guy is going to use the same technique in order to attack the system. So if you figure out, for example, the user Alice use guessable password, you're going to notify the user, please change your password because your password is easy to guess. We don't do this one in IIT, but this one thing that I hope if we can do that. In many we rarely find any organization do this one. But this is one interesting thing. The other thing is called the complex password policy or proactive password checking. Again, still we have the same goal. We try to eliminate the guessable password at the same time allowing the user to choose or to select the password that is easy to memorize. Okay? So in this case, the user is going to be allowed to use the selected password. But at the same time, the system is going to check and say, oh, this password is weak. You're not allowed to use this one. Try again. Try again. This is too short. Okay? It doesn't contain this or this or this. It's easy to guess. For example, if the user chooses 1, 2, 3, 4, 5, 6, it's rejected. Okay? How can you perform that? We have different ways in order that. The first one, we can use rule enforcement to enforce specific rules. When you choose the password, I'm not going to allow you to proceed or finish this step until you follow these rules, until you adhere to these rules. The length, specific character, special character, special character, and this mixed uppercase and lowercase, etc. And also, you are not allowed to use the previous password. Okay? Another thing, password checker in this case. So here I can come up with bad not used list password in my system. It's not allowed. For example, this is a list of password that I don't want the user to use. This is a guess. For example, I can use the most common 1,000 or passwords used in this last year or this year. We have 1,000 or 10,000 common password. Then here, every single user try to use the password. I will check this one. If I find this one in the not to use list, I'm going to reject this one. I'm going to say, choose this one, another one. That's one thing. Of course, you need to find a way in order to have like fairly fast tests, okay? Because the user, you need to make sure the system is still convenient. So I need to come up with algorithm, fast algorithm, or lookup table, or algorithm allow me in order to do this one in a more efficient way. The other thing, we have a Markov model or Bloom filter with different way in order to try to generate. I'm not going to combine or generate like specific password. I'm going to use this model in order to try to generate a guessable password and reject anyone that might generate, or Bloom filter, which is another way in order to build this table that contains hash value. Then after that, check with the desired password against this table. If this exists, then it's going to be like rejected. So we have many techniques in this case. So one defense for the password, I'm going to make selection strategies. After you select the password, I'm not going to say, leave the password going to be unlimited. It's going to be unexpired. The password must be expired. And it depends on the time. Some of them 90 days, some of them 1 year. Now at IIT, 2 years. Now maybe they do this one 3 years. I think a few years later, I'm going to do this one for unlimited. You can use the same password forever. Okay? That's what might be helped, but the problem with this one, if the user have a short period of time, for example, it depends on the system. It might be if you work with a FBI or let's say CIA or whatever, or any government agency, may be required to change your password more frequently. So every month, every week, every X, whatever. Okay, so in this case, there's a chance maybe you're gonna forget your password. Okay, Well, it's going to be costly because you need to perform the password. Just set the questions. Maybe you need to call in order to help desk in order to help you in order to change the password, and etc. These just funny pictures. For example, she changed her password. Okay, she used the dog's name as her password, and now she is fine. Everything is fine. Now her dog name is this name, and change her dog name every day because her password is associated with her dog name. Another thing with the password expiration, with that we don't like, when they enforce the user to change the password, maybe the user is going to tend to only change one character. Okay, please in this paper, you check this one. It's interesting. You see that the people that are lazy change only one character at the end, or maybe change only one letter. I need to use the same password. 1, 2, 3, 4, 5, 6. Oh, I need to change 1, 2, 3, 4, 5, 6, 7. Change next year 1, 2, 3, 4, 5, 6, 7, 8. Or 1, 2, 3, 4, 5, 7, 6. Switch or swap only the 2 letters at the end. This is finally they change the password, and they can keep the username and password the same. Okay, or maybe people get forget the password. Yeah, every time they change. Another way in order to handle these different passwords, maybe you can use, say, password manager. Why the user should have, user remember every single password, different accounts. Maybe have like password managers with gonna store all these passwords, encrypt all of them passwords under a single master password. Then one password is gonna allow you in order to access all the systems. Okay, this is one option you can use. We do have another issue with the password here. We have too many passwords to remember. One solution, as you mentioned, we can use the say password manager in order to solve this one. Okay, but since sometimes you're gonna have too many passwords to remember, and the problem with this one, maybe end up we have someone gonna repeat the same password, or use the same password with different accounts. And why this problem? If someone compromises one system, an account in one system, can use this one in order to access the accounts on other systems. Okay. There is another issue associated with the password. Failure to change the default password. Many systems, many routers. People can, or the bad guy can use a social engineering and phishing in order to try to attract the people to say reveal their password. Some error message in the login system gonna give you sometimes contains the password. For example, some old system when you try username and password, gonna say the password is wrong, or the username is wrong. So what this means? Oh, the password is correct, but maybe associated with another user, something like this. There's a bugs in the system, might be this one, or can be exploited by the bad guys in order to achieve the password. Keystroke, for example, logging, spyware, etc., allow the bad guys to somehow in order to find out the way in order to get this password or credential for the user. Or the user, and then with the weak link in any security system, you're gonna do what? Share the password. Okay. There's another issues, okay, which is interesting actually. If you take a look at this paper, use the reflection. You're sitting in the past, waiting in the past, and you try to type username and password to log into your phone, or maybe the code in order to access your phone, iPhone, etc. Someone behind you recording you, then after that steal your phone, then gonna get access to your phone. Done. That's one thing. Or you log into your account, bank account, whatever, you type username and password, and this guy can get, just recording and get the information that's stored there. That's one thing. Okay? This is shoulder surfing, okay? In both cases here, shoulder surfing, or the reflection in your glasses. And of course, this is just, a paper, but at least this one, it works. Get some, interesting result that we can gain something. I'm talking about the bad guys who try to reflect the change or get, recording whatever you're typing, even on your phone. Okay, another interesting technique that allows bad guys in order to steal the password, like an experiment based on this paper. We try to have the iPhone, which have the malicious code, we try to set next to the keyboard. This one try to record or identify whatever key you struck in this keyboard. Because whatever text, introduce the whatever keyboard or nearby keyboard. Which is one interesting way. If we have this one, that'd be interesting. You set next to someone and you record whatever you type, and then after that you retrieve this one, you can guess whatever the password that you're gonna ask. We do have many password leaks. This thanks for interesting, let's say, strong systems that we have in the whole system, and we keep hearing. I'm just sarcasm in this case. We hear almost every day there's some leaks, there's security leaks somewhere in many systems. Okay, just an examples. And based on this information, the bad guy is gonna analyze the leaked information in order to see how people doing the password, whether they're gonna have more sophisticated technique, whether still using the easy password to guess, or maybe the people improve and doing better job in order to choose the password. Okay, just an example. One of them for the Yahoo, my interesting, perfect, examples. Yahoo disclosed, the breach in 2013 first. And they said that a group of hackers had compromised 1 billion accounts at the time. Then after that, they revised or changed their estimate to the 3 billion user accounts in 2017. You see, 3 billion user accounts has been compromised. Okay. Another example, which interesting example, I guess, this one, Marriott and Starwood data breach. Okay. The interesting this one, in 2018, Marriott International announced that hackers had stolen data about approximately 500 million Starwood hotel customers. The interesting with this kind of attack is this attackers, during this attack, had gained unauthorized access to the Starwood system back in 2014, either remaining in the system after the Marriott acquired, I think, Starwood in 2016. The discovery wasn't made until 2018. So they stay in the system, attack the system since 2014, and they didn't discover the attacker. They still gained access to the system, remain in the system almost 4 years later. So see, that's the interesting kind of attack. They attack the system, remain in the system undetected, and keeping collecting information. And all the information that they got about, I think, the travel information of the customer and the personal information, and I think, the debit card, the credit card, information about the credit card are more than 100 million customers were stolen. You see this? This is interesting information that we can get. This sample example, you see that based on the information that we can leak, okay, and it's going to be affect the system, overall system. So the bottom line of the password attacks are too easy, but it's very important, be convenient to use. Okay. Often you need only 1 weak password in order to break the security of the system, to get access to the system. User choosing the password. Okay. And social engineering attacks help in order to guess, to figure out, collect information that help in order to attack the system or to get the password in general. And the bad guy always has all the advantage. Okay, password is a big security problem and will continue to be a problem. Okay, and also the passwords are not going to disappear anytime soon because it's easy, convenient, free to use. Okay, we do have another technique, another way, mechanism we can use in order to authenticate the user. But since the password is easy to use and free, convenient, you didn't need to do anything, it's not going to cost me anything just to memorize the password, so still many systems still use. So we have many videos. I'm not going to go over all of them, but interesting to take one example, funny videos, okay? Just try to, someone try to ask the people about their password, and the people, you see that automatically going to say, oh, this is my password. Okay? So it's easy to, as I mentioned, it's easy. In order to get the password, just try to ask for it. Okay? There's another interesting website. Links, you can watch them. The first one, I know your password, interesting one. If you have the time, I encourage you to take a look to these videos. Okay? Then one interesting reading, if you cannot see, how could you choose the secure password? I know all of you use choose password. You definitely going to choose you're already choosing secure password, but it doesn't hurt if you learn more about that. Let's take a look to watch this short one video about what's your password. Hopefully it's gonna give us like funny shine. Of course, that's will say I'm not gonna make fun of people, but at least see how easy people can share their password.
To this this hack, this Equifax hack, I mentioned earlier, they may have compromised the information of 143 million Americans, which is a lot of Americans. So in light of this, as a service to the public, we've actually done this before, and it's very effective. We asked people who are passing by our theater today what password they use to protect their personal information. And pay attention, please, because there are a lot of important tips to be shared here.
We are talking to people about the cybersecurity breach at Equifax, and in light of that, we're asking people how secure their internet passwords are. What do you use for an internet password?
You know, I usually stick to my last name. That's probably not the best thing to do, but I usually stick to my last name, a few digits, maybe like a hashtag or something, or...
How do you spell your last name?
Walker.
Walker?
Yeah.
W-A-L-K-E-R?
Yeah.
And then just a few numbers?
Yeah, I probably should have told you that.
And then a
but-
hashtag.
Yeah.
Okay.
Yeah.
The numbers, like, what do you use, like your birthday or something, your area code?
Yeah, usually like my birthday,
How old are you?
21.
21? The day you're born?
November. No, the 29th.
29th of November?
Yeah.
So Walker, 11/29/95.
Woo! I probably shouldn't say that, but
That's okay.
yeah.
How strong is your internet password?
Strong.
What sort of things do you use?
Capital letters, lowercase letters, numbers, characters, everything.
What's the current password you're using?
I don't really want to tell the current password that I'm using, to be honest.
You think I'm a hacker?
Not necessarily. Well, I mean, I guess, you know, like 63XJ9 hat symbol, at symbol, basically. All characters, pretty random assortment, and I just try to
Can you use
memorize.
that one?
Yes.
Thank you. What is your internet password that you use for your email?
In and Out 2017.
That was easy.
Thanks, sir.
Thanks.
My internet password is capital W @TER capital B 0 NG water bomb.
Yeah, we got it.
My internet password is okay.
Yeah.
Mila what's MILR64.
Well, that's nice. Now Americans can hack into a Russian website. No, that'll be fun. Hello, sir. What is your name?
Jerry Reed,
Jerry, where are you from?
Whittier, California.
What do you do out there besides scare school children? How strong is your internet password?
I'd say pretty strong.
Yeah. What sort of things do you use for it?
You know, things that I like.
What sorts of things do you like?
Maybe a dog, an animal, a place I've been, someone I know.
So like Rover mental ward.
Yeah, something like that.
All right, well, that's Jerry.
So what do you think? As I mentioned, it's easy to get the password by direct ask people about that. It does mean that everyone gave you the right password, but somehow you see they give you some hint and see that it's easy to get this password. Maybe this one part of the show, but at least give an idea that, I mean, I'm interested, I believe some of them, because, based on experience, it's easy to get the password direct from the people. Okay? Exactly. That's what I said. It's easy. And even, again, I'm repeating myself, the easiest way to get the password is by direct ask about the password. And you're going to be amazed at how the people are going to voluntarily give you the password. Okay, so now let's take a look at something different here, since we still have time. So we covered everything about the password, I guess, that we want to cover in this part. And now let's take a look at different way to how to use it, alternative way to use in order to authenticate the user. Remember the goal to user authentication. We need to prove the identity of the user. We need to convince someone else with the system that I'm the person who claims to be. When I try to log into my system, I need to prove my identity here. So I'm going to talk about the token-based authentication here. And again, I'm not going to go in more details, just give you an idea what's going on. How can you achieve this goal? How can you perform a user token in order to access the system? Okay? So objects, generally speaking, that a user possesses, okay, for the purpose of the user authentication are called tokens. We're going to talk about the tokens. With anything that we have, okay, and for example, we try to log in or use a card, in order to prove to me that your card, you're going to unlock your card using the key. So you have something in possess. In order to, for example, to log into the system, maybe I'm going to use the MAC address, or maybe I'm going to make the access based on the MAC address. Which is that one way to do the firewall. That's what when you set up your, let's say, router in your home computer system or the home network, what you're doing in order to restrict the access to the system based on the MAC address, right? Of course, there's a way that bad guys can, mimic or change their or impersonate the MAC address, but at least with the home user, it's okay, kind of give you like guarantee that no one else except these MAC address can allow to access the system here. Okay, or cell phone. In order to make sure that you have a token cell phone, what I'm going to do, I'm going to send you code to the cell phone and ask you, please, you need to just enter the code that I just sent you. So when you type this one, it's going to prove that you possess this one, the cell phone in your case. Okay? So again, something in your that you possess, okay? You need to prove that you already have possessed this, whatever this factor, in order to authenticate the user in general. So again, objects that users possess, okay, for the purpose of the user authentication are called tokens, and we have different types of tokens here. By the way, yeah, ATM card, the credit card, etc. All of them are token, okay? You can possess. So a security token, as I mentioned, can be a physical device that used in order to gain access to the electronically restricted resource. For example, as I mentioned, we try to log in to the IT or say the Stewart building after 5 p.m. So you have to use your student ID or your ID card to scan. There's like reader machine installed outside the building. You need to scan in order to allow you to access. Okay? So generally speaking, the token is going to be used in addition or in the place of the password. It depends. Sometimes you're going to provide the user username and password. Then after that, as a two-factor authentication, the user is required in order to use, let's say, a token. Okay? Or as a situation in the IT or the Stewart building or the IT, when you log in the system after the 5 p.m., so you need just to provide the token as authentication. And I need this one a different way, of course. I need just to allow you to access to the system. Of course, in others, they are going to record the log who access when. So we're going to be, there's a database somehow, we're going to record the log entry. Everyone, so you're going to say, when you scan your ID, the system is going to check whether the ID is available or not. Is it allowed to access the system? Yes. Allowed to access this building? Yes. So we're going to record, for example, the student Alice at the time, specific time, the date, access this building. Okay? So we have a different types of token, or cards can be used as tokens. Okay, it can be memory, it can be smart cards. Okay, I'm not going to go over all of them, okay, just to give you an idea here. So the memory cards, generally speaking, can store, by the way, I'm going to examine only two types of tokens here. I'm not going to go more details, just give you an idea, okay? Because the main focus here, I don't have time to go over all of them, more details, so just give you like two types of tokens. I'm going to talk about the memory card and smart tokens in general, okay? And I'm going to show you that how can we use this in order to perform the authentication. Okay, the first one, again, take a look at the memory cards. The memory cards can store but not process data, with kind of tokens that can be only stored information but cannot process data. Okay, and the most common such card is the bank card with a magnetic stripe on the back, which contains information. Okay, so this magnetic is going to be only store the symbol security code, for example, which can be read by the card reader. And by the way, the card reader is not expensive, so it's easy to find this one on Amazon and anywhere, and I'll use this one in order to reprogram this one. Okay, there's some device available online, you can use them in order to reprogram this card. Okay, there's another memory cards that include an internal electronic memory. So some of them maybe have some memory. Okay, these memory cards can be used alone for the physical access. For example, like the hotel room, They have like a memory card you can use. Just scan this one, allows you to access the room, etc. It's easy to reprogram. Okay, once you leave the room and you leave the hotel, they're gonna use the same card to reprogram in order to allow to use by another customer in order to access his or her hotel room. Okay, for the computer user authentication here, these kind of cards are typically used with some form of the password or personal identification number. So we are not going to use this one in order to authenticate for this one in order for the user authentication of the computer. So use this one plus the PIN, or let's say, or for example, if you try to use in the ATM machine, so we're going to use a card, then after that you have associated with another authentication factor. For example, it's going to be PIN or code. Okay. Of course, we have the card going to be combined with a number, and a PIN number is going to provide more or better security, right? Instead, you have only the card, because in this case, if someone steals or stole this card, so it's going to in this case cannot be used without this PIN code or PIN number. So it has like some disadvantage or drawback with using these memory cards, because it requires special reader, which is going to be costly compared to the password. Password is going to be free, inexpensive, not expensive, because all you need to memorize your password. Here, I need to have a special hardware that can be installed in the front door or at the access point of every single or the system or your computer. Try to use this one in order to authenticate the user in order to scan or read this card. Okay, it has to say when you lose the token. Okay, when a lost token temporarily prevent, for example, the owner of this token in order to gaining access to the system. At the same time, if someone has found this token, maybe gonna use or maybe gonna forge this one, then after that, the only thing that we need in order to find out the PIN, and usually the PIN is not hard to guess. Usually the PIN code is what? Is 4 digits. So you have, using any computer, you can guess these PIN. Or maybe you're gonna reprogram this one. Okay. The other drawback using the memory card is user dissatisfying in usual. So although the user maybe have no difficulty in accepting that they use the memory card for the ATM machine, it's fine. Yeah, when you go to the bank, yes. You use the credit card, yes. Can you use this one to authenticate with the user system, account system, or for example, we try to log into your computer. It's inconvenient. Because you see this one, we try to log in your computer. I measure that you're going to use a name and password, then after that you have to scan your memory card somehow in order to log and enter the PIN, then after that allow you to access your computer. It's unacceptable. It's not convenient. Okay? So that's the memory card. The other type of the token we're going to talk about here is called the smart tokens. With the smart tokens is like we have many devices kind of qualify as the smart tokens. These, when you say smart tokens, you need to have, we can categorize this one into, let's say, 3 dimensions or 3 different categories. The first one based on the physical characteristics. The second one based on the interface. The third one based on the authentication protocol that you use in order to authenticate itself to the system or the machine. The physical characteristics of the smart token as follows. Okay, generally speaking, the smart token is gonna do what? Include an embedded microprocessor. Gonna have the microprocessor installed inside this one. Okay, the smart token is gonna be looks like a bank card. Okay, which can be called in this case a smart card. Other smart token can look like, you say, calculator. Maybe have a key. Maybe have like portable object, etc. If you take a look here, please go back here. Something like this. You see the smart token here. This one option, and this is another option here. Someone's going to keypad, you can allow you to interact to get the password, or the key, you're going to see how can you use this one, use the authentication, or there's one, another one, a crypto card, for example, if you click here, reset, it's going to produce what? It's going to generate, let's say, one-time token that we're going to use in order to authenticate the user, and etc. So based on the interface, so we have as a manual interface, includes might be a keypad, okay, and display for human token interaction, or electronic interface, which is the other one as I show you here, the one that you have electronic interface, or the other one that have a keypad here. They can, you need to somehow to communicate with the reader and the writer, okay. One of them is going to be here with contact, other one contactless. One of them you have to directly have scanned this one using the reader on the writer device. The other one just you need to be close to the whatever the close distance to the reader device, which you can see that some credit card right now, contactless. You get it closer to the reader in order to perform the payment here. So it depends different types of interfaces here. And the other thing, what's interesting thing, you can categorize the smart token based the way that how to authenticate itself to the system in general. We can have different types of authentication. The first one is static. That means in this case, the user authenticates himself to the token, then the token can authenticate the user to the computer. Okay? The most using one is based on the challenge response. Before talking about this one, please take a look at the dynamic password generator. One of them, this interesting way. This time is in order to authenticate the user to the system here, because you have to position this token, and you're going to use this one in order to authenticate yourself to the system. Okay? So in this case, the token is going to generate like unique password. Every minute, of course, not every minute, every time you try to log in the system or every specific time. Okay? So then you have unique password every time you try to log into access. Okay, this password can be entered to the computer either automatically or maybe if it's USB. Let's take a look here, back here. Either here, every time you're going to generate a password here, either here or here. Okay, either going to click reset this button every time to log in the system, and this is the now the current password they can use here. And either going to be type this one by yourself to the system, or automatically when this one is going to be blocked to the system or the computer, automatically going to generate the password. Then after that, they're going to be fit this one to the program. Now it's going to be what? It's going to be authenticate user in order to authenticate the user to the system here. At the server side, we're supposed to have the same password going to be generated at the same side or the other side. Okay. So the targeted computer system must initialize and keep synchronized. For example, here at the client and here the server. I want to collect this, log into the system. Now I can press the button here. The password is going to be 1, 2, 3, 4, 5. At the same time, the server must now generate the same password, must be generated. Synchronized. The first password is going to be, every time to log in the system, the next password is going to be, for example, 2, 3, 4, 5. So when you log in the system anticipates and can put, yeah, the password must be 1, 2, 3, 4, 5. Next time we try to log in the system generates the next, or the device, the token generates the new password. And the system going to generate the same new password, must be the same one. So that's why it must be synchronized. And kept synchronized every time to log in the system. Otherwise, we cannot authenticate the user, right? So in this case, I'm not going to store the password somewhere. When I log in the system, I need to generate a new password in order to allow me to authenticate the user. The other one is called the challenge and response, which is an interesting one here. The challenge and response, every time you perform the system or access the system, you need to prove your identity. For example, you are a client and this is a server. You say, hey, Alice, for example. This one, going to say, prove it. In order to prove it, I'm going to say, okay, I'm going to challenge you with the response. Send you a challenge. For example, maybe I'm going to send you like announce. You know what you mean by the announce? With the number used only once. Okay? When you send me that, okay, I need to make sure if you are the one as or the one who claims to be this, I challenge you with this one and prove to me that you are the person who claims to be. The simple thing we can use what? Public key encryption scheme, yeah? So the client here, or the Alice, can use what? It's going to be encrypt, for example, the private key of Alice of the announce are, okay? Then send the encryption here, all right? The private key. So the sender, or the server here, in this case, when you receive the response, the simple thing is decrypt using the public key of Alice for whatever I receive, the value here, and see whether the value of the announce here will the same one that I generate or send it to the Alice or not. If I have the same one or whatever, the announce +1 or whatever, it depends on the protocol I'm going to use, I can make sure it's going to be authentic. The user say, okay, I know that the user who the one who claims to be, no one else. Because the only one has the possessive, they say, the private key of the Alice, it's Alice, no one else. All right? So this one kind of challenge response here. So the computer system generates a challenge, random string or announce. The smart token going to generate a response based on the challenge. And the same thing, we can use a public key cryptograph. cryptography in order to achieve this goal. Okay. The smart card was one part of the smart tokens. Okay, is one of the most important categories of the smart tokens. Has a piece of the credit card as I mentioned here, and also gonna have like electronic interface in order to communicate whatever the compatible read-write device that we have. Either gonna be contact or contactless. Okay, maybe gonna use any of the smart token protocol to authenticate with the reader or the computer. It might use the static or the dynamic protocol, or maybe gonna use a challenge of the response. It depends. Okay, it contains microprocessor. That means it can perform some computations. Okay, generally speaking, have a co-processing with extra, piece of the hardware, which allow the smart card in order to perform cryptography mechanism, encryption, decryption. Okay, it can generate digital signature. It can decode, encode the messages. It can validate the information transformed and etc. Or transferred, etc. It has different types of memory. Read-only memory, that's not going to change. So the read-only memory is going to contain what in this case? It's going to contain or store the data that doesn't change during the card's life. For example, the card number is going to be stored here. The card holder name is going to be stored here because it's going to be non-erasable information. It's not going to be changed. The other kind of memory it might be erasable, programmable room, I think EE room in this case, which might be hold the application data and also the programs that we need here. For example, what kind of protocol this card must execute? It can be stored in this room, EEPROM, okay? And we have a random access memory, which of course, since we're going to perform some computation, etc., we're going to use some RAM in order to allow us to know to execute the application. This what kind, for example, encryption scheme can be stored here, and here we execute the encryption scheme, for example, now it's going to be executed in the RAM because it's going to store somehow the RAM here. Okay? So it's going to hold, temporary data generated when the application are executed. Okay? That's all about this kind of cards, okay? We usually, I don't have time to go deeper to see how can we use them in order to authenticate the user. But remember, we still rely on the password because the password is easy to use, is not expensive, they don't need to cost us nothing, and easy to maintain. For example, if you use a smart card in order to allow users to log into the system, if the smart card lost, that means we need to issue a replacement card, which is going to have some effort and cost. In order to use this one, you need to have some machine allowance also to, let's say, compatible reader-write, and machine allow reader-write the data here from this card. We talk about the two factors authentication in general. Two factors are going to be two steps, for example. One authentication, maybe another authentication factor. You can use two different authentication factors. And you see right now the most popular options, email and the cell phone. We try to log into the system that they're going to send you the message or the code in order to allow you to confirm your identity to log into the system. Especially when you log in using different browser or new browser. And you have one option. If you say we're gonna save the access from this browser or not, I encourage you, don't do it. Every time you prefer to use two factors, better than you store disable this one by just saying trust this browser. Okay. Another thing we need to go over this one since we have a few minutes. Yeah, I need just to finish this part. Then after that, I will stop with the purpose because the purpose is one authentication. How can you remotely authenticate the user? Remote authenticate user, okay, or user authentication remotely. We try to use access server or service that is not next to you. This is far away using the internet. So that means somehow we need to send this information, the authentication user information of the authentication factor through the internet. So anyway, before I go over this one, let's give you a quick idea about something that you are or is or have in this case. We talk about the biometric authentication here in this case. So what do you mean the biometric authentication here? And it's just to get over to say, attempt to authenticate the user based on the unique physical characteristics. Okay, by the way, let me go over the disadvantages of smart card authentication, although it's not listed here, but I just remember this one, interestingly know why you don't use them. There are good features in the smart card in general, but they have some limitations. The first one, lack of user mobility. You cannot move this one from one place to another place. You need to have like a special hardware in order to access these or use them. Okay, it's costly card readers. You have an extra piece of information. We're going to add more extra cost in order to implement this one. That's why we don't see this one everywhere in the IT. We have some places you're going to use a smart card that will allow you to access the system because it's expensive. They don't use everywhere in this, for example, even for the offices and etc. Only for the labs and the server room and etc. Okay? A slow performance in this case, because when you implement the smart card authentication, it depends on some infrastructure. Maybe going to be slowed down their performance. Because right now, especially when during the initial loading, when the user log in to the workstation at the beginning here. So we need to make sure that hardware meets, for example, the minimum specification for the smart card authentication, and also this one is not going to affect the overall performance. Remember, if you try to authenticate the user to log into the system, compare using the password, compare using the smart token. The password, type the username, ID, and the password, enter, done. And you need just to compute the hash value with the salt, and after that, find if the match with the hash value stored in the system that allows the user whether to access the system or not. For the smart token, different story. I need to first read the smart token first. Then after that, reading gonna cost. They're gonna spend a long time. Then after that, you're gonna perform the authentication protocol in order to make sure that they have the same right password or not. For example, the smart token, you're gonna generate, say, periodically new password. You need to synchronize this one with the server. At the same time, you need to make sure that the password is gonna be matched. So it's gonna be, affect the overall performance. Can easily get lost. You can lose them. Yeah. Yeah, lightweight, yes, user can easily lose them or maybe break them without noticing. That's the problem. So we need to perform change them or replacements, ask for replacement. Anyway, something you are, as you mentioned here, we're going to use a biometric authentication in this case system, which attempts in order to what? In order to authenticate the user based on his or her unique physical characteristics. For example, this includes the following. Might be static characteristic. That means something that never change. Your fingerprint, for example, your facial characteristics, and etc. All of them is going to be like unchanged. Maybe someone is going to say, yeah, I can change my fingerprint. Yes, if you try to use some acid, that to erase this one, that's different the story, yeah. Or maybe you're going to use, I know, we saw this one in the movie, and they use this one. They try to copy the fingerprint for someone, then after that put this one in your fingerprint. That's a different story. But I see for the user itself, it's never changed. Okay, this kind of information is static. All dynamic characteristic, which is going to be, for example, the voice print, so your signature. Your voice, for example, you speak in the morning is different than your voice, for example, when you speak in the night. Or your voice when you were younger, 20 years old, is going to be different when you're 30 years. So it's going to be changed. Maybe you have flu, so your voice is going to be changed. That one is going to be dynamic characteristics. It's going to be changed with the time, okay? So, in generally speaking, the biometric is what? Is based on the pattern recognition. So when you say pattern recognition, that means I need to see somehow, I'm not going to find 100 exact match, but I try to find a way like match, for example, 60%, 70%, maybe 80% to whatever pattern that I have. Okay, I'm going to talk about this one in the next slide. So anyway, compared with the password, okay, the biometric authentication is both technically and complex. Technically complex and also expensive in order to achieve this one. Even compared to the password and the tokens. This one is expensive because you need a special tool with hardware in order to allow you in order to scan the fingerprint. Then after that, you need to find a way in order to extract the features and just allow you in order to tell whether this one has a match or not pattern here. We have many physical characters. We can use them. They have many of them. Okay, and while it's used in the number of specific applications, they use the biometric authentication, but the biometric has not, let's say, be used as a standard tool for the user authentication with the computer system. Maybe things can be changed in the near future, but right now, because it's expensive, it's not accurate 100%, so, and costly, so stay away and complex, then so we tend to use the password and the tokens if we need to make two-factor in this case. Okay? So just give you an idea about what you mean by the cost and accuracy. Why is the biometric authentication? We talk about something different than when we talk about the password and token. For the password, when the user log into the system and you're gonna provide username and the password, and I'm looking for the exact match. Here's now. So the concept of accuracy doesn't apply on the user authentication schema that use the smart token and the password, because I'm not saying it's like 90% match or not. I need to have exact match. This is the password, must be hash value of the password, and must be find exact match. Okay, here is different. Here I'm the biometric parameter authentication here. The system in this case, instead you're gonna find an exact match, determine how closely the presented biometric characteristic match a stored one in the system. Okay, when you have his fingerprint, the system I guess maybe tried to find 19 or 20 points match. If you find 20 point match, this is enough. So you're gonna tell for sure this ID with 90% maybe has a match with this guy. For the password, the token again, no, different story. We have to have exact match. So if you take a look at the accuracy of the cost, even between the different biometric authentication techniques here, if you have a voice and face, for example, or signature or hand, the accuracy is gonna be too low, and the cost is gonna be too low. But the IRC, if you use this one, it's gonna be expensive. True hardware allow you to achieve this goal, or read the data or write the data. At the same time, you're going to achieve higher accuracy. Okay? So time is over. So I will stop here. The next lecture, I'm going to take a look how can you talk about the generic biometric system. Then after that, go over, the interesting part, how can you remove user authentication. Then go over more details about the corpus.